Basically, the topic of this talk is about, as you can tell from the title, crossroads for cloud and networks. And basically, it will showcase how cloud domains and the network domain have actually married together, and they have actually led to what we know as network softwareization. So basically, cloud experts and network experts, they were working completely separate from each other. But then, in the context of 5G, these two areas or these two expertise had to merge to give us what we know as network slicing, network softwareization, network function virtualization, software-defined networking. And this is exactly what I would like to, introduce to you. Of course, I understand that the audience should be having different background, and that's why I will make the talk very high level. So I'm not going into any technical detail, but if you're interested, you are more than welcome to visit our website, of Mosaic Lab, and, check some of our relevant publications. All right, so before I talk about this crossroad of telco and cloud, I'd like to briefly introduce Mosaic Lab. So as I said, Mosaic Lab is part of the of Aalto University, and more specifically, it's part of the Department of Communications and Networking, which is part of the School of Electrical Engineering. In this lab, we have actually 4 main research directions. The number one is about technologies, techniques, algorithms, mechanisms, for creating these programmable mobile networks. And that's really what I would like to introduce to you today. And that's in the context of network softwareization. When we speak about softwareization of networks, it's not limited only to networks, but it can be also softwareization of service delivery platforms, like the ones we use when we watch YouTube or we watch Baidu videos or whatever, and that's actually content delivery network. So the second research direction is about softwareization of CDNs and information-centric networking, ICNs. The third research direction is actually about how we can use UAVs, these unmanned aerial vehicles, and we equip them with Internet of Things devices. And then with this, we can actually create a platform that can operate, that can provide us with Internet of Things services on demand and from the sky. So basically, I think if I recall well, I gave a talk about this topic, number 3, some time ago at Tianjin University. So just for those that have attended the talk. But then security for us, I mean, whenever you want to provide any kind of cloud or network service, security is very important. And that's why we've been looking into how we can provide security in this kind of softwareized networks. And here we look into how we can use network function virtualization technologies, software-defined networking technologies, so we can provide security on demand and actually in much more customized way. So these are actually the 4 main research directions. In the team, actually, we do lots of hands-on, we build test beds, and we have strong, actually, hands-on experience with many open sources like ONOS, like, Kubernetes, of course, like we use OpenStack, LXC, Docker, for containers. And, even we contribute to some of these open sources like ONOS and also LXC. All right, so now let's come back to the talk of today, which is crossroads for cloud and networks. I think we all know these requirements of next generation mobile networks, and basically we speak about 5G. I think, there has been always demand for high capacity, better reliability, better efficiency, mobility support. And also, when we talk about in the context of 5G, I think all of us, we know about the strict requirements in terms of latency. I think there is requirement from 1 to 10 millisecond end-to-end latency. But in my humble opinion, these requirements are very important, although I think many of them may not be met as we wish for, in 5G. And that's why actually some of the requirements will be heavily investigated in the context of beyond 5G or 6G. But, in my humble opinion, one of the most important requirements on 5G is this. And this is basically, I copy it from Ericsson. So where they see that 5G is a platform that is supposed to support not only nowadays services, but the ones that will come in the future, the ones that will come, say, in 5 years from now, or 10 years, and so on and so forth. And in one word, the system has to be very agile. You don't want to design and invest in a very big system, very expensive system, just to support, X number of applications nowadays. And then in 5 years, when you have a new service, then you will be having problems and you need to, upgrade or even redesign the whole system. This is not the way anymore. That's how it worked in the context of migration from 2G to 3G to 4G. But in 5G, they said, let's do the things differently. So one important requirement on 5G, in my humble opinion, which is also a feature, is this agility. The system has to be agile. Also, in the context of 5G, we're not talking about individual end users, but rather we talk about verticals, X number of, vertical that brings huge number of end users. And all of these end users, they have to be connected to the system with the same, service level agreement. And here we talk about automotive, we talk about energy, food, agriculture, healthcare, so there are lots of actually verticals that are actually considered in the context of 5G. Not only that we need to support verticals, but we have to accelerate the delivery of their services. So basically, you're not talking about the launch of service that would take 6 months, but no, you want it sometimes to be launched in a matter of few hours, if not few minutes. And this is a very important requirement. I think cost efficiency has been always very strict, requirements, but in the context of 5G, it became very, very crucial. And the idea is, no matter how powerful, the network that you design, it will be always limited in the amount of data that it can deal with. And basically, that's actually a paradox, because you bring a very speedy, very powerful technology, more people start using it, more interesting services start emerging, and then you have to deal with lots of data, and then you realize that actually your system is not good enough. That you need more equipment so you can support the data. But the problem is, this is okay, to invest in the equipment more and more when there is return on investment. But the problem in the context of even 4G and beyond, that you have to invest in equipment to support more data, but at the same time, this average revenue per user is actually getting down and down. And this was expected, or predicted even since 2008 by Cisco. So this is the dilemma that many mobile operators are dealing with. Traffic goes all the way up, but the average revenue per user is almost stagnant. In certain cases, it even goes down. So we need to design a system that is cost efficient. And these are actually the features or the requirements, in my humble opinion, that define the whole 5G or the whole beyond 5G system. So the system has to be cost efficient, has to be agile, has to be elastic, and this is relevant to the cost efficiency. It has to be flexible. You need to have a system that is flexible and rapid in the deployment of the service and also in the support of the relevant vertical. So when we look at these requirements or these features, actually this brings us to the concept of network softwareization, and this is the definition of it. So it's actually an overall transformation trend for designing, implementing, deploying, managing and maintaining, network equipments and network components by software programming. And actually, I don't want to read all the things there, but basically, the idea is turn the network equipments into a piece of software that can be executed on any kind of virtualization platform or any kind of cloud, and have the network itself being deployed as a cloud service, as I will be explaining later. And if we do it, then we will be able to somehow achieve these features, which are actually unique features of cloud computing, at first place. So what are these objectives of network softwareization? The number one objective is to transform the mobile network equipment into virtualized software components. So basically, I don't know how many of you are familiar with the network equipment functions. Oh, Yeah. So basically, we want to have them as a piece of software that can run on the net, as I said, as a piece of software on the cloud. But not only that, we want even to decompose them into microservices. So basically, you know, it depends on the network function, but you know, sometimes I can decompose it into a function that does only the touch, a function that does actually paging, a function that does actually mobility management, a function that does billing, and so on and so forth. And basically, based on the service that I want to launch for the network, I can just call those microservices and link between them. And this is the second objective, is basically link between them following the standardized interfaces. And if I do this, then I can build an end-to-end network which is suitable for the service or the vertical that I have in mind. Like, for example, social network like, you know, service like Facebook, or automotive, or Internet of Things. And I should be able to create and manage, you know, these networks and manage, you know, their life cycle. So that means manage them, create them from the beginning, and manage them, you know. This is basically, you know, the two main objectives of network softwareization, you know, in a very, very brief and very high level way. Of course, when I do this, that's actually what we call, I create a network slice, which is consisting of the right amount of resources, virtual resources, running on them the right types of virtual network functions, and even, you know, linking between them. And that's actually, you know, with certain amount of resources, bandwidth, or, you know, network resources. And that's actually how we define a slice. To clarify the idea even much more further, what's a slice? What does a slice mean? Basically, this is what we have nowadays. We'll be having a cloud that could belong to Amazon, another one that could belong to, I don't know, I don't know, Alibaba, for example, in China. You have the network which belongs to, you know, China Mobile, or I don't know, like China Network, or, you know, mobile, you know, fixed mobile operator. So basically, this is what we have. Nowadays, if you go to Amazon and you say, all right, just give me give me a virtual machine with a certain CPU, with a certain, you know, storage, that's actually you asking for only computing / storage only resources. And in my opinion, that's what I would refer to as computing / only slice. If you go and you create a VPN, for example, from a certain point, from a server in China to another server which is outside, so you can access your Gmail, and this is exactly what I do always whenever I visit China. So basically, you get in certain amount of resources of networking, and in my opinion, you can do multiple VPNs, even you specify from which point to which point, and that's actually, it will give you only networking resources, only slice. Basically, this is what we knew since a long time ago as an overlay network. You can go further, and you can go to Amazon and you say, all right, give me a virtual machine with 4 cores, with a certain amount of storage, blah, blah, blah. And then even you specify what kind of function you want to run on it. So for example, you can say, I want to have a DNS running there, or load balancer, or Nginx, you know, which is a streaming server function. And in that way, you get what? You get the computation, you get the storage, and you get also the virtual network function as a slice. You know, you can specify where they should be. But now, actually, this is not the types of slices we want. What we want more than that. Actually, that's what I refer to as a full-fledged slice. I would like to have the right amount of virtual cloud resources. I run on them, you know, the right types of virtual network functions. I want to have between them, you know, this, you know, certain amount of bandwidth, you know, between each VNF and each VNF. And even if I place things, if I move this VNF to this one, you know, the connectivity between them should be done, you know, should be, you know, maintained in a completely transparent way. And that's actually what we refer to as software-defined networking. So basically, this is what we are looking for, a full-fledged slice, which consists of the amount of cloud resources, and we run on them, you know, the type of software that we want. And we want to make sure that the connectivity between each, you know, each element of that network slice with its counterpart is actually being done, you know, following certain amount of bandwidth resources. This is the full-fledged slice that we're looking for. And this is exactly what really defines, you know, this marriage between cloud, or this crossroad, which is the title of today's talk, the crossroad between cloud and telco, mainly when you use virtual network functions that are actually softwares of the network itself. for example, the PDN gateway of the 4G system, or the serving gateway of the 4G system, or the SGSN, you know, of the 3G system, or the user plane function of the 5G system, and so on and so forth. And actually, when you do that, you will be able to create actually multiple slices, and each slice could be good, you know, for a certain type of service. For example, you would create a slice which is good for mobile broadband services, like, you know, 4K or 8K streaming. You will create another slice which is good for automotive, another slice which is good, you know, for Internet of Things, you know, massive Internet of Things, and so on and so forth. And basically, you know, nowadays, actually, the limitation that we have, you use the same mobile phone, you connect to the same network, to the same mobile operator network, so you can access actually different, you can access WeChat, you can access Baidu videos, YouTube, you know, different. So basically the same network that you are using for different services that definitely have different requirements. The future is actually, it should be different. It's actually when I have this mobile phone, but when I click, for example, just this is an example. If I click on Facebook, I go actually my data of Facebook, they're not transmitted to me over, you know, any kind of network. No, but it's actually transmitted over the network slice, which is created in a customized way and in a suitable way to that Facebook service perspective, you know, characteristic. The same thing, you know, if I click on a streaming service, then, you know, it is being, you know, the packets of that streaming service being actually handled by, you know, the network slice, which is suitably, adequately, you know, created for the streaming service. And you continue like that. So basically, you know, the same mobile phone is connected to multiple network slices, and each network slice is actually handling packets of certain service in a completely different way. And in this way, we can really achieve, you know, that much needed differentiated service concept. So basically, you know, each service will be treated in a very, very specific way, and the way which is actually suitable and optimal, you know, for the service in question. And of course, you can be having always, you know, one slice which is default, and it can be used for, you know, kind of like best effort service, or for, you know, voice communication, and so on and so forth. All right. So now let me show you this crossroad idea of cloud and network. So nowadays, if we use, I mean, I don't know what kind of example I can give you from, but let's say that we use WeChat. You know, if we want to use WeChat service, is basically we have the WeChat, you know, messages, and WeChat, you know, data, you know, our profile, and so on. They are all of them stored, you know, in the cloud that is being used by WeChat. All right. But then we need to have connectivity to, say, to China Mobile, so we can actually access, you know, WeChat. All right. So this is exactly the, you know, nowadays, this is what we do. Like if I use Gmail, my emails, everything, and my profile is everything in the Google data center, but still I have to subscribe to specific mobile operators so I can actually access them. But actually with this network softwareization, the objective is to extend the concept of cloud computing beyond data centers. And that's actually towards mobile end users. So not only that our data and our, you know, service being stored in the data centers, no, the network itself, which can connect me to my data or to my service, is also offered as cloud service. So basically the radio access network, the core network, and also, you know, the data center, which is running, you know, for me, the service, everything is offered to me as cloud service. And this is, in this way, we can achieve mobile connectivity, decentralized computing, and of course, smart storage, because we can decide where to store what. All of these are offered to me as one end-to-end atomic service, and it comes with all of these nice features of cloud computing, which is elasticity, multi-tenancy, pay-as-you-go, which is cost efficiency, agility, because I can actually make things, you know, in a very agile way. And this is exactly how we can really achieve those requirements or those features that I have mentioned earlier of 5G. Of course, there are many enabling technologies, but the key ones, software-defined networking, I cannot talk about it here. This by itself, it would require like at least 2 hours or 3 hours, you know, of introduction. Network function virtualization, I just gave like really high notion about it here. And then, you know, cloud computing, of course, or edge cloud computing if you bring the cloud towards the end user. When you talk about the virtualization of a mobile network, and this is one aspect of this crossroad between cloud and network, of course, you can virtualize the data plane only. You can do that. You can virtualize the control plane. By the way, what I'm using here is just one reference architecture of 4G, but the same thing applies, you know, to 5G. You can do only the radio access network or any composition of these segments. So you have actually that flexibility in doing this. Now, for me, with this end-to-end network softwareization or end-to-end network slicing, I really I see it like it's going to define a very interesting journey for us to a very innovative world. And let me explain my idea. So basically, before, you know, Apple started emerging, you know, let's say before even, you know, the beginning, you know, in the beginning of 3G, I would say even till the year of 2004, we had actually the network landscape was like this, in a sense that the user equipment was locked. Basically, that's why we had very ugly phones. Radio access network was locked, and it is still locked. It's basically the ownership of one mobile operator. The core network, the same thing. It was like under the ownership of a single mobile operator, and it's still the case. You know, the network was designed under the assumption that the services will be under the control of the mobile operators. That means if you want to have access to any kind of service, you have to pay extra money for it. In my humble opinion, when iPhone and the like, you know, emerged, you know, what happened, the biggest success was that actually the user equipment, of course, they got nicely designed. But in my humble opinion, the big success that actually they were open. Basically what that means, it means they were offering APIs, you know, to mobile application developers with specifics, you know, operating systems and so on. And they say, okay, you can develop any kind of service, put it on, you know, Google Play Store or iTunes, whatever, and let the people, you know, download them and, you know, enjoy them. So in this way, what we had, user equipment got open, the services got open, and that's why we started seeing a lot of innovative services. So just by opening these two segments, we started seeing many interesting services and many innovative services actually emerging. So actually the journey within 5G and beyond is actually to open these two segments. And this is exactly what I would like to explain. So basically we started already by softwareizing the components of these segments, the radio access network, the mobile core network. Basically in my lab, we have, you know, the virtualized EPC open air interface, you know, which is from Uricom. And in this way, you know, first step that we could virtualize them, we can run them as a software on you know, on containers, on virtual machines. And then the idea is actually, the next step is actually offering suitable interfaces to vertical providers, mobile application developers, so they can actually call the system and they say, all right, I want to have a run deployed for me with this specifics and the core network deployed for me with this specific. So my end users can actually access that network and, you know, through that network, access my services. And this is already, you know, somehow, you know, the beginning of it happening in standards. And this is, I would call it like the network exposure function, which is in the 5G architecture. So in my humble opinion, once we open all of these segments, you know, lots of innovation will happen, and only one's imagination can be limited to what we can do with this. Basically, we will be able to create multiple slices for different, you know, services, different verticals, and that will be very interesting. And this is exactly, you know, the idea. It's like I create network slice, which is good for a certain service, like social network, automotive, Internet of Things, and so on and so forth. The thing will become even more interesting when we can offload, you know, the computation, you know, because we have mobile phones that are actually quite limited in terms of capabilities. So if we can offload their computation to the cloud, then a lot of interesting services that we can run, that we cannot run, you know, at the user equipment because of the limited processing power, we can have them actually at the cloud. And here, even more and more interesting services will emerge. And, you know, the project of Google Glasses, or the project that Apple actually is talking about, eyeglasses and so on. So basically, when you have those devices with very small chips that do not have to do much processing, just displaying the things, but everything is happening, actually all the computation happening at the very nearby edge cloud, you know, lots of interesting things will happen in my humble opinion. Sophie, I think I'm almost at 10. I still have more slides. So how am I doing in terms of time?
Well, okay. You can just talk about maybe for 5 or 10 more minutes.
Okay, 5 more minutes. 5 more minutes. That would be good enough. All right.
Great.
So in my humble opinion, if we can do this that I have mentioned earlier, then we can achieve all of these features of 5G that I have spoken to you about, which is cost efficiency, agility, elasticity, flexibility, rapidity, and so on and so forth. And in my humble opinion, 5G, we had lots of interesting requirements on the 5G system in terms of latency and in terms of spectrum efficiency, in terms even of capacity. Many of these requirements could not be met, in my humble opinion, mainly the latency one. But the true success story of 5G was actually that he could really bring, you know, these two areas, cloud computing and telco or network experts, you know, joint expertise and try to do something which could be meaningful and useful for both systems. Of course, all of this based on some basic principles of software engineering, because we talk about the virtualization of network equipments, you know, the softwareization of network equipments, and things have to be done, you know, following the principles of software engineering. And this is, you know, open source. This OpenStack is just one example that has actually a very big community, which is consisting of people from cloud computing and also people from telco domain, and also people, you know, from the software companies and so on and so forth. So in my opinion, that is really one of the biggest success of 5G. I think the cloud will be having a much stronger presence in beyond 5G, because still we have lots of things to do. For example, to achieve the concept of multi-service, multi-tenancy, with all the security, with all the isolation we are actually in need of. Softwareization and the network slicing, yes, the functions themselves, they have to be redesigned. And also there is this network exposure function, which I have spoken to you earlier, which is these APIs, these interfaces that I have to expose to the outside world, to the third party, so they can actually deploy the network. So still lots of things to be done there. And then the network itself has to be really cloud native. I mean, the network equipments, when they are designed, they were designed that they have to be static, but now they have to be really cloud native. That means I can, you know, shuffle them, put them anywhere, and I keep moving them, and nothing should be, no disruption should happen, you know, to the network as a service, and also to the service which is running the network. And by the way, this is already happening in 5G. So basically, this is the concept of service-based architecture, and still lots of improvement should be happening within standards, you know, to achieve these, at least these 4 requirements, which is being loosely coupled services, extensibility. The functions have to be very modular, which is the microservice concept. And also we have to be very open to third parties via well-standardized northbound interfaces. So this is it. The network architecture shall be truly cloud native. Actually, nowadays, when we do networking, for example, we define routing. We say, okay, from this point to that point, you know, you go via this route and this router and this router. But actually, cloud will be also part of the routing itself, because, you know, maybe I will send a packet that has to be processed at certain data center. And after, you know, being processed in that data center, it goes to another data center. Then probably some additional processing should happen, you know, till, you know, the final destination. And this is what I mean by, you know, cloud being, you know, part of the routing itself. And this is exactly the concept of segment routing. So this is just another aspect of where cloud will be having a very important role in the networking and in the routing itself. You know, it will change actually the concept of routing as, you know, differently from what we know it up to now. Artificial intelligence. Of course, now everybody is talking about artificial intelligence. And in my humble opinion, this AI will be having a very important role in beyond 5G. Already, you know, things have been, you know, start happening in the network, you know, among the network experts. So for example, we have this network data analytic function, which is being standardized in 5G. And basically, you know, if we have very good usage of cloud, and also we leverage it, with AI, and we understand, how the behavior of end users and so on and so forth. I think this AI plus smart connectivity, it will be impacting different aspects of our life. And these are just like some snapshots that I took from the promotion video of 6G flagship, a national project here in Finland that I'm part of. Lots of interesting use cases that will be supported, and that will be, impacting transportation, healthcare, impacting, different sectors, automotive, and so on and so forth. Even our meetings, now that we are having actually these virtual meetings, but in the very near future, we'll be having this kind of teleportation, holographic communication, to conduct our meetings without the need for traveling. And I think Corona and what we are experiencing these days is something which is really going to push very strongly towards that direction. All right, so in my humble opinion, as I said earlier, 5G has been able to put expertise together from cloud, telco, and also software engineering. I think 6G or the beyond 5G is the technology that will be bringing in, the AI stakeholders. And I think, the future, in my humble opinion, will be very, very bright and very interesting. And that will be defining lots of interesting research challenges for us as academic researchers. And I think with this, I come to the end. I thank you very much for your attention. As I have promised you from the beginning, I want to make the talk very, very high level. But if you're really interested in knowing what we do concretely, technically, in terms of research, you're more than welcome to visit us at our website and check, some of our relevant publications. So thank you so much, Shawfei, and the floor is yours for questions.
So let's welcome Professor Mohsen Guizani. Okay.
Thank
Mohsen.
you, Shawfei. Thank you for the nice introduction. Thank you, Tarik, for a very nice and informative talk. The outline is, as you can see here, I will talk about some motivation at the beginning as an introduction, and then talk to you about the properties and requirements for 6G, since it's still a future technology, and talk a little bit about some research activities that we are involved on related to 5G and beyond. So we all talk about a smarter future, and smarter future involves all of these applications that you see in this slide. From smart energy to smart mobility to smart water to public services to making buildings smarter in terms of air conditioning and heating. I won't read all of these applications under each of these topics, but what's important is the bottom where we look at smart integration. That means we have to integrate all of these different applications. For instance, if we are looking at or designing a smart city, as you know, there are a few smart cities in China, and here in Qatar we have Lusail. There is a smart city in Dubai. There are many prototypes of smart cities. So in order to be able to achieve the smart city notion, we have to integrate all of these so that all of these applications and have these to be smarter. So what enables us to what are the technologies that enable us to achieve this smarter future? As you all know, it's the cloud that was invented about a decade ago, where the cloud provided the services, but with a major delay. So then we went down and created the edge or the fog, where the applications are closer to the user, but still for lot of emergency or a lot of requirements, then people are started to think of the MIST applications, which involves the IoT devices together. For instance, an example of the MIST is vehicular communication. For instance, instead of downloading a video from the cloud or from the edge, why don't I get pieces from my colleagues who are around me in the same room or in the same building, where I can share with them my information and I can get parts of the video that they have watched already and I need to watch right now. So we are talking about at the lower level here, we're talking about billions and billions, tens of billions of IoT devices, Internet of Things devices, as you can see here. I mean, and as you are aware of these types of applications and the types of and the huge number of these IoT devices. So our research activities in my research group revolves around three themes, where we look at large-scale Internet of Things deployments. We look at the fog and cloud computing issues, where we look at vehicular smart system, for instance, intelligent transportation, and so on and so forth, and future applications where we, as this talk, where we're talking about 6G and the applications that it can support, which is expected to support very complex systems. And our research activities are supported by different agencies and different industry, whether here in Qatar or elsewhere. So in terms of the number to get to this complex system, or to this smart city that is ubiquitous and has lots of requirements, looking at the statistics in the last few years, it was the world population, more than 50% of the world population lived in cities, in metropolitan areas. And it is expected that will increase to more than 60% in 10 years from now. So that, if you can imagine that if today we have 2 to 3 gadgets that have to be connected automatically, our smartphone, our maybe smartwatch, and maybe a laptop, in few years, by 2024, 25, it is expected that each one of us will have 6 to 7 devices that have to be connected automatically, and that brings lots of challenges and requires that our systems or our network has to be intelligent, has to be very ubiquitous, has to be smart enough, and that's where the 6G or 5G and beyond comes into place, where it is expected to be intelligent enough, smart enough, where it uses different learning techniques that as we'll talk in a minute. And in addition to the intelligence and the AI that you know about and that is required, we expect to have an interdisciplinary approach to design these smart systems and to create these prototypes for the future. So we need to have enable smart but secure living for the people, from intelligent mobility, from different platforms. Healthcare is really a nice and required application, where I mean it has been very important in the past few years, but it's essential these days, especially during the coronavirus, as you all know. How to use these new technologies like blockchain, whether in healthcare or in other applications. I talked about smart cities in the last. How to apply the machine learning and the intelligence in these. So as you can see, we have to have an interdisciplinary approach. That means if you are working to develop a smart city, you have to talk to a city planner. If we are saying that healthcare is very important and make the healthcare applications so intelligent, we have to talk to nurses and medical doctors so that we can know what applications they need. So in that case, you have to develop robust algorithms that optimize these things very efficiently, whether be it in health systems, intelligent transportation, urban resilience, and big data, of course, because big data is the key to these nice applications. So with this introduction, with this motivation, we come to 6G. So 6G. Let's look at what drives us to look at beyond 5G and 6G, while we haven't even arrived to 5G, as you know, except for Huawei, or that they have been implementing 5G already. I know here in Qatar, Huawei already implemented 5G and will be available very soon. So the driving applications for 6G, as you see on the top, is the multi-sensory XR applications. XR means extended virtual reality. So we expect that by using 6G, we expect that that will be. It is expected that will be the end of mobile phones, because everything will be wearable. So we'll have as Tarik was talking about beyond 5G and beyond, that our glasses will be smart enough, our suits will have all the sensing and all the touching and all the intelligence that will allow us to communicate without having a smartphone or a mobile phone. The second driving application is, as you all know, is the connected robotics and autonomous systems. You see these days the research in our research communities, the research that is very active and very fierce on UAVs and robotics, and the 4.0 industrial revolution will be based on the smart robotics and autonomous systems. Then the next application is the wireless brain-computer interactions. So as I mentioned, for the virtual reality, there will be you don't need to have a computer that is separate from your body, or separate from your brain, or separate from your eyes. So there is an integration of technology and human perspectives, so that everything will work automatically and without any intervention. And finally, in terms of the applications, is the blockchain and distributed ledger technologies. As you know, blockchain has revolutionized the financial industry, and these days it is really revolutionizing healthcare, revolutionizing transportations, revolutionizing medications, pharmaceuticals, and so on and so forth. So these are the 4 driving applications that will eventually lead 6G to success. Then we go to the driving trends. So without going through the details, as you can see here, the driving trends are a lot of those. So you can see we have 1, 2, 3, about 7 major technologies or trends that are driving the 6G. So that is from the development of the new technologies in the wireless era, in the technology, in the antennas, and so on and so forth. So just mentioning a few more bits into spectrum reliability. So we have more bits in the spectrum. We have more reliable spectrum, smart enough. We have spectral and energy efficiency, which is referred as CSEE. We have systems that are smart enough to use the energy available in a smart manner, and to make sure that reproduce energy while working. So we don't need in the classical way to chase the batteries all the time or provide energy at any instant. We have emergence of smart surfaces and environments. So surfaces on top of buildings, or the buildings itself are smart enough. They have coatings. They have different electromagnetic and holographic surfaces that are smart enough to be able to help in increasing the bandwidth and reducing the noise, and so on and so forth. Massive availability of small data, from self-organizing networks to self-sustaining networks. Not only self-organizing networks that are separate, as Tarik was talking about in the first talk, but also sustainable. What's important is to keep the network intelligent and keep it working for a long time in terms of emergency and so on. And so on and so forth. The convergence of communication, sensing, control, localization, which is called the 3 Cs, the communication, the control, and the computing. And the end of smartphone era that I mentioned earlier. The third trend is the enabling technologies. The technologies, as I said, are here, and that include the above 6 gigahertz for 6G. That means we have now the 6 gigahertz plus that is available now, whether be it implemented in millimeter wave or other things. So that it can mobile for mobile millimeter wave and terahertz. We have transceivers with integrated frequency bands. So the technology is there. The enabling technology is there. We have communications with large intelligence services, as I mentioned earlier. The surfaces that are holographic now, that reduce noise and increase bandwidth. We have an integration between the satellites, the UAVs, and the base stations. You know, so there is an integration between terrestrial, airborne, and satellite networks that can support. There are technologies that can support these the 6G. We have energy transfer and harvesting, as I mentioned earlier, and we have beyond 5G. So those are the so back to the applications. So I mentioned the first enabling technology for the 6G is multi-sensory XR. XR is virtual reality, augmented reality, and multivariate reality applications. You know, everything related to devices that we wear, whether be it eyeglasses, whether be it smart suit, whether be it smart jacket, and wristbands, and so on and so forth. Connected robotics and automotive system, which is called CRAS. Okay, wireless brain-computer interactions interactions between our brain and the wireless system became very common and very useful. A blockchain and distributed ledger, as I mentioned earlier, technology, and I won't read all these because I already. But what's important here, I want to emphasize, is the convergence of communications, computing, control, localization, and sensing, which is referred to as the three CLS, the three communications, the three C's, which is communication, computing, and control. L is localization, and S is sensing. In the past 20 to 30 years, we were talking only about the three C's, which is the communication, computing, and control. But now we added to it the localization and sensing, because sensing now is too important. As you know, we'll talk about some applications later in this talk about the sensing and how we collect the huge data in order to analyze that data and make the right. And the end of the smartphone era, as I mentioned. Sorry for this table is not very readable, but I think you can get the idea in terms of what is needed, in terms of what we have right now, requirements for 5G, what we need for beyond 5G, and what will be needed to make 6G a success. And that starts from application types, the device types. I mean, I won't repeat what I just said, but what's important here, I want to make you aware of the rate requirements and the end-to-end delay, because those are two requirements that are very important. So you can see for 5G we have for 5G we have the 1 gigabit per second. For the beyond 5G we have the 100 gigabits per second. But for the 6G is 1 terabit. So you have to keep in mind as researchers. I mean, this is very very important, and it's very challenging. It needs really a huge technology to be able to achieve the 1 terabits per second. In addition to this requirements of bandwidth or rate, it is really the challenge, the biggest challenge that Huawei faced. And I talked to their representative here in Qatar, and he says it is really very, very challenging and very tricky to be able to reduce the end-to-end delay from 5 milliseconds for 5G to 1 millisecond to beyond 5G. I mean, so coming from 100 milliseconds, if you know about 4G and 4.5, it's 100 milliseconds. So for 5G, it's 5 milliseconds, the end-to-end delay, and it's 1 millisecond for beyond, but it's expected to be less than 1 millisecond for 6G and beyond. And this is really a very, very challenging requirements. And I want you to think about it and look at, read more about it, because this, if you can, if any of you or any of us can solve this issue, and the reason, I mean, we can talk about the details in another talk, but the reason the challenges is the noise, the delay embedded, the errors that are available, and to bring it to less than 1 millisecond is really, really very challenging. And if one of us or any group of us can solve this problem, I'm sure you will get the Nobel Prize. So keep working on this, and hopefully one of us will get it, or a group of us, hopefully. So read more about this, the end-to-end relay and the rate requirements for 6G, and you'll see what I'm talking about. Of course, there are other requirements which I won't go through due to the time, but probably in another talk or something we'll talk about this. So what are the services that are available? The service classes that are available in order to so we have what's called the mobile broadband reliable. So the latency, as I was saying, the end-to-end delay is so important that we call it, as you probably heard of, URLLC. I'm sure it's ultra reliable lower latency communication, URLLC. Now in 6G we're talking about massive URLLC. Massive means to bring it under less than 1 millisecond is so important, is so huge, is a huge challenge that everybody today is working on. And I encourage you and encourage our graduate students to work on this, because it is really very interesting and will bring a lot of bring you a lot of recognition. We have the human-centric services, where we said that the human are involved in this, and we have the 3 C's and localization and sensory. It's so important. The 3 C's again are the communication, computing, control, and localization and sensing. As you know, localization is really a huge topic right now. I mean, to be able to localize something inside a building or inside the room or in a field that is a catastrophe like we see today is very important. The enabling technologies, as I mentioned earlier, the 6 gigahertz and above. Okay, so we're talking from small cells that we are talking about in 5G to tiny cells in terms of 6G, and that will be available because of the millimeter wave and terahertz frequencies. 6G will be talking about tiny cells. So as you know, the more cells you have, the more interference you will get and the more noise you get. Therefore, you have to make sure to reduce that noise. I mean, so the controversy is to get the delay, the end-to-end delay, to less than 1 millisecond. At the same time, you have tiny cells. So you see the contradictions in these requirements, which makes the 6G very big challenge. And then we have the communication with large intelligence services, LISs. The LISs, as I mentioned, they are surfaces that will reduce noise, that will help in the communication, that help in increasing the bandwidth. So reducing the noise and increasing the bandwidth, which is called that includes high spectral and energy efficiency, the C that I mentioned earlier, and the holographic radio frequencies and holographic MIMOs, MIMO, that we are familiar with, but making from holographics. The edge and artificial intelligence. As you know, that artificial intelligence now is involved in all our research, and we're talking about the collective network intelligence, where we in 6G and 5G and beyond, we are looking at reinforcement learning in particular. So reinforcement learning, as you know, we have different types of learning techniques, but reinforcement learning is the key to making the edge intelligent. We talked about the enabling technologies, terrestrial, airborne, and satellite, where we integrate all of these together to be able to serve the 5G applications, the 5G technologies. Energy transfer and harvesting. We have to have technologies that will transfer energy and harvest energy, because we are not at 6G and beyond or 5G and beyond. We don't have the luxury to be able to change the battery every few hours, or we have to have, for instance, for devices that we use in healthcare inside our bodies. We came up with ingenious technologies where because we cannot make a surgery to change the battery on an elderly person or a sick person, we have to recharge those using our heartbeat, using the heat of our bodies, and so we have to come up with ingenious ways for energy transfer and harvesting. And then other enabling technologies is what are the standardization for 6G and beyond. Actually, for beyond 5G, as Dr. Tarik was talking about the standardization and different. We're talking about quantum computing. You may be familiar with quantum computing. Some of you are familiar with quantum computing, but not quantum communication. Today, quantum communication is a hot topic where quantum communication, if we are able to achieve quantum communication, then we have a 100% secure network, because quantum communication can provide you with security. So go read about quantum communication, or we can talk about it. I have another lecture about quantum communication, which provides us full security, so we can talk about it another time. The integration of radio frequency and non-radio frequency links. That means the integration of all the technology together to serve the 6G. That is the optical, the neural, the molecular, and other channels. All the channels that are available have to be integrated to be able to serve as the enabling technology. So this is just the slide summarizes all of the things that are necessary to make 6G a success. Some of the technologies or some of the applications I talked about, and some others I did not, but they are summarized here. I can provide you with the link to this. Finally, for the 6G is this nice picture, 3D picture, where it talks about the three main objectives to achieve the 6G is the data rate, the reliability, and the latency. We talked about the latency that should be less than 1 millisecond. We talked about the data rate that will be 100 gigabits and plus, but reliability is also very important. So this shows you that this three-dimensional graph shows the relationship between these three main components, these three main parameters that will make 6G a success. And you can see here the URLLC. You can see the mobile broadband, the extended mobile broadband, the mobile broadband RLLC, and so on and so forth. These are the different technologies or the different parameters that will make 6G a success. Now, in the next few slides, how much time do I have, Shafi?
Mohsen, maybe you have maybe several minutes. It's okay.
Okay.
Yeah.
Okay. So just to give a hint, I actually finished with the 6G requirements, but I want to talk a little bit about what kind of applications we can do as wireless communication or communication people here, because I know most of the people attending this are communication. So where can we see these new technologies will be supported? Can IoT help? Can blockchain help? Can machine learning help? Of course, I mentioned here and there where these can help, but I will go quickly on what we are doing right now for these. Of course, each question is a talk by itself. So I will go quickly. As you can see here, for IoT, I will answer the first question very briefly. I will answer the first question. Can IoT help? Of course, IoT can help in healthcare, because we are interested in healthcare. My research group works in healthcare and interested in healthcare. So when we're talking about healthcare, we're talking about sensors that are around our bodies or inside our bodies, that will collect data, and that data is huge, as you know, big data, and we take that data and we analyze it, we translate it, and we into actionable insights where medical doctors can make the decision. So we are interested lately in what's called implantable medical devices, IMDs. Implantable medical devices are devices that like brain simulator, like heart defibrillator, like insulin pump, and so on and so forth. So these are, or the pill that we swallow, that an elderly person or a sick person swallow, that goes through the stomach and through the intestine and through the body and sends images outside, so we can collect those images and make it. So you can see here the challenge is to reduce the energy to develop new lightweight cryptographic schemes, because these IMD devices, or these devices that we use in our bodies, that they are so small and they don't have enough computational power, they don't have enough energy power. So we have to we have to be able to reproduce the energy, or automatically make the energy reproduce, and develop new schemes, new security schemes that are lightweight. And we have done that, and these are the security issues. I'm concentrating here about security. So this slide is very important. A few years ago, I had a master's student who come from the biology bachelor. So from biology, I was talking to him about security. How does our bodies fight against viruses like what we have today, the coronavirus? He says, well, our immune system, the human immune system, is really a very intelligent system, because it recognizes the virus automatically without any human intervention. It produces enzymes, produces defense mechanisms that will defend against the virus, and will eventually kill the virus without any human intervention. So we want a system that is lightweight, efficient and accurate, and adjusts and recover every time a new virus comes. So we expect that we have developed some schemes, and we have published them, and if you are interested, we can share them with you. So we developed some schemes, and we believe that the best security schemes in the future should be similar to the human immune system, to the body immune system that defends, that recognizes the virus, recognizes the attacker, will defend against it automatically, and produce enzymes that is against that. Of course, in addition to quantum communication I talked about, because quantum is very secure and will be. So we use some body features, but we can use other body features in terms of making the security, and use different learning algorithms like genetic algorithm, water filling. So this is a summary of the IoT itself. The IoT is not only the devices, is the identification, plus the sensing, plus the communication, where 6G comes in, plus the computation, where the 3CLSs comes in, the sensing, the services, and so on and so forth, where it will work for these complex systems, whether it be tracking and monitoring in health systems, or in intelligent transportation, or in troubleshooting massive structures like the power grid, like the satellites, like going to the moon and going to Mars, and so on and so forth. And these are some of the ideas of research challenges in the future, and these are some of the 6G open research topics. As I mentioned earlier, actually this table summarizes the open problems, and I emphasized on them earlier. The main open problems is the high data rate for 6G and the low latency, the massive ULLC that is available.
Hello everyone, my name is Xiongze Hui. I'm from Alibaba NTU Singapore Joint Research Institute in Nanyang Technological University. My topic today is towards the future data market, reward optimization in mobile data subsidization. So let's start. Here is the outline for my subsequent presentation. First, I will briefly introduce the data subsidization systems and describe the system model as well as the game formulation. Next, I will present the ADMM-based multi-leader, multi-follower solution. Performance evaluation parts will be then provided. At last, I will give a summary and shed light on some future directions. As we know, the demand of cellular data is rising sharply in the last decade, and the high data costs become one of the critical concerns for mobile users while consuming the content. So under such a situation, one urgent question for the network operators is how to attract more users. Recently, the concept of mobile data subsidization or sponsored content has been introduced as a new promising business model. As example here, in certain applications, if we watch some news that is marked by sponsored content, then we do not need to consume the content while reading it. Data subsidization scheme or sponsored content scheme is an emerging business model, which has been proposed in many famous operators such as AT&T and Verizon. In this scheme, the CP is allowed to pay a network operator such that their users access content through the network services from the network operator with a lower charge. This concept has generated a positive cycle for the network operator, content provider, and users. In other words, we can say the content provider can sponsor the user for their data consumption. The user wants to access more content which will not be counted into their data caps, and the content provider can encourage more users to have higher data demand for contents. Accordingly, the higher demand contributes to the more profit of the content provider. Therefore, the sponsored content or the mobile data subsidization scheme leads to a multi-win situation. Clearly, a key challenge here is how to provide proper sponsorship. In this paper, we mainly study the game theoretic interactions among the three entities under the sponsored content policy. There are some important properties in such interactions that motivate us to consider game theory. First, the entities in mobile data subsidization can be fully rational in nature. They make rational decisions with only consideration of their individual objectives. Furthermore, the decision-making can be in a distributed operation, and the strategic interactions need to be captured. All these requirements make a game theory approach naturally suitable. In this article, we aim to address this sponsorship problem in a unified game theory-based framework. However, most of the existing works on mobile data subsidization consider that users can only consume the content with advertisement, that is, the sponsored content, and passively accept the corresponding reward. The only active strategies in their works are to choose how much sponsored content they demand. In addition, when there are tremendous numbers of providers and users in future mobile data market, for example, the constraint optimization and the traditional game theory methods are practically inapplicable in terms of the complexity and scalability. Nevertheless, both of these two challenges has not been well addressed in existing literature that motivates the study of this work. We consider a system with mobile data subsidization in which there are M-heterogeneous content providers (CPs), such as video CPs, YouTube, Netflix, and Hulu. The CP can subsidize the mobile data usage of N-heterogeneous mobile users. The users can access and consume the content from different CPs, and the content can be downloaded directly through the network infrastructure. The data usage of user can be partly subsidized by CPs while displaying a certain amount of advertisement. The CP earns advertisement revenue when the user accepts the offer data subsidization. Meanwhile, the users are able to reject reading the advertisement and still access and consume the content paying the full data usage fees without subsidization. Following most of the existing work, we can define the utility formulation of the user with content demand y, and which is expressed by the first equation, where sigma is denoted by the utility coefficient and p denotes the price. And the utility of the user, which has the content demand y that accepts the subsidization from the CP, is formulated by the second equation, where tau is denoted by the advertisement discounts. We first assume that the user, that is the buyer, decides on a fraction of content demand to access that accepts the data subsidization denoted by x. Then the fraction of content demand of that not accepts the data subsidization, that is the normal content demand of user, is 1 minus x. Note that we normalize user's action to sum up to 1, that is 1 video content. Nevertheless, the analytical results will not structurally change even if the content demand is not normalized. Then we can denote xij and θij as the content demand of user I that accepts data subsidization from content provider j and the reward factor of content provider j for user I, respectively. Now we can define the reward factors of each CPJ, theta j. Similarly, we can define the content demand strategy of user I, xi. Each rational user I decides on the strategy of content demand from different CPs that maximize its utility, where function of fx is the non-decreasing and concave with decreasing marginal satisfaction, and the sum of omega ij is 1. The definition of omega ij is the probability of user I to choose CPJ to access the content. On the other side, each CPJ aims to maximize obtained total profit, the gain advertisement revenue minus the cost of subsidization, which can be formulated as the first equation, where μj denotes the advertisement revenue. By adopting the incentive mechanism method in the existing literature, we set the probability of each user I choosing CPJ as the second equation. Now we have two optimization problems for the MU and the CP. Considering the inherent leader-follower relations among CPs and MUs, we model this two-sided interaction problem as a hierarchical game. In particular, we model the problem as a multi-leader, multi-follower stable game, in which the CPs are leaders and the MUs are followers. Consequently, Problem 1 and Problem 2 jointly form a stable game with the objective of finding the stable equilibrium. As per the definition of 1, we can define the stable equilibrium as the point where the payoff of the leaders is maximized, given that the followers adopt their best responses. In mobile data subsidization system, the solution of the game has a practical meaning of importance. In particular, if the existence of stable equilibrium is proved, the CPs and MUs can potentially reach a market agreement to trade content with data rewards. Each individual CP competes with others for the equilibrium, which is constrained by the lower equilibrium among the users, leading to the equilibrium problem with equilibrium constraints. That is EPAC formulation. For this EPAC problem, we also follow the basic idea of backward induction and consider the subgame problem among MUs with the fixed CP strategies. Clearly, we have the following lower equilibrium condition among users. With some technically rigorous transformations, we can formulate the CP's optimization problems as the following EPAC problem. The EPAC describes the hierarchical optimization problems that contain equilibrium problems at both the upper and lower layers. As aforementioned, the CPs are independent and rational entities, which aim to maximize their individual profit. However, maximizing the profit of CPJ affects the profits of other CPs and the utilities of all users. Likewise, the utility maximization of user I affects the profits of all CPs. In practice, when the number of CPs and the number of users are very large, the centralized optimization in terms of profits and the utilities of all CPs and all users, respectively, is difficult to achieve. Furthermore, in the multi-CP, multi-user scenario, the coordination of multiple conflicting paths lead to high complexity to achieve the optimum results. In this case, the conventional methods seem to not very well handle this multi-leader, multi-follower game problems because of such a high dimensionality of each player's strategy space. Therefore, we propose to utilize the distributed ADMM algorithm with a fast convergence property for the above large-scale optimization problem. ADMM is an effective large-scale optimization tool for solving convex or even non-convex functions. We elaborate the iteration process of multi-CP, multi-user-based ADMM that is leveraged to optimize the profits of CPs and the utilities of users in the framework of mobile data subsidization. Specifically, each iteration is composed of two-layer optimization, utility optimization in lower layer, and profit optimization in higher layer. In the lower layer, each user I observes a announced reward factor from CPs at the start of each iteration Q and decides on the content demand strategies toward different CPs. Note that the superscript Q here represents the Q's iteration of the ADMM in the external loop. The objective of each MUI is to maximize its individual utility UXI and obtain the optimal values of XI. This forms the internal loop of the ADMM. In the higher layer, the CPs are aware of the behaviors of MUs due to the first moving advantage, and hence they can predict the content traffic to be transferred to users. Specifically, each CPJ controls the value of CTJ to maximize its profit by invoking ADMM. The updated reward factors are then broadcasted to the user for the next iteration, that is the Q+1's iteration. This forms the external loop of the algorithms. The external loop will not terminate until the condition in line 6 holds. We can further validate the convergence of algorithm 1 with theorem 1. In this part, we employ the numerical results to justify the system performance metric in mobile data subsidization system. We here first confirm the convergence of the distributed ADMM algorithm in the data subsidization system with 3 CPs and 3 users. The EPAC problem is solved in an iterative manner. In particular, the results in Figure 2 shows the convergence of computation among users to achieve the lower layer equilibrium, and the results in Figure 3 shows the convergence of computation among CPs to achieve the higher layer equilibrium. Different users and CPs finally achieve different payoffs at the convergence point. Then we've studied the system performance of a general data subsidization system with MCPs and NMUs under the proposed scheme. We assume the utility coefficient of users and advertisement revenue coefficient of CPs follows the normal distribution. Specifically, we evaluate the performance with different number of users and CPs, as depicted in the figures 4 to 7. Performance with different number of users and CPs, as depicted in the figures 4 to 7. From figure 4 and 5, we can observe that the total utilities of users and total profits of CPs both increase with the increase of the number of users. The reason is that the more users will consume more sponsored content, which results in more profits of CPs. Nonetheless, as the number of users increases, the marginal increase of the total utilities of users and total profits of CPs both decrease. This is due to the limited data subsidization constraints. As the total reward is limited, the CP cannot provide enough subsidization for our users when the number of users is very high. Therefore, the increasing rate of the total utilities of user decreases as the number of users increase. In addition, we observe from figure 6 that the total utilities of user increase, but the total profits of CPs decrease as the number of the CPs increases. The reason is that the competition among CPs becomes sharper when there are more CPs in the system. Each CP competes with other CPs to promote its content traffic by providing more subsidization for users. Therefore, the total profits of CP decrease in presence of sharper competition. Meanwhile, the competition among CPs results in a greater subsidization to users, leading to the increase of the total utilities of users. Now let's turn to the conclusion and future direction parts. In this work, we establish a hierarchical stable game to model the strategic interactions among multiple content providers and multiple users in a subsidization ecosystem. To explore the reward computation, we formulate an EPAC problem to characterize many-to-many interactions among multiple providers and multiple users. Considering the inherent high complexities of EPAC, we employ the distributed ADMM algorithm. Taking advantage of the fast convergence property with the high scalability of ADMM, we derive the optimal solution with a reasonable complexity in a distributed manner. Numerical simulations are conducted to demonstrate analytical results and evaluate the system performance in the proposed scheme. There are quite a few interesting directions that we can further explore. First, we can incorporate the involvement of network operator in this work by implementing a three-stage stable game. Also, the uncertainty of user types might be addressed with the help of machine learning methods such as deep reinforcement learning. Moreover, we will further consider the bounded rationality of decision makers. In this case, the perspec theory from behavior economics can be used to describe user behaviors. That is more psychologically accurate. Okay, that's all. Thanks for listening.
Hello everyone, I'm Wei Dai from the Chinese University of Hong Kong, Shenzhen. It's my pleasure to be here and to represent our team to give the presentation. Our topic is private cloud in 6G network, a study from the total cost of ownership perspective. Through our work, we hope researchers can pay attention to the cost analysis research in private cloud. In this presentation, firstly, I will give a short introduction about our topic. Next, I will show our literature review on the total cost of ownership in cloud computing. Then, I will compare and contrast the public and private cloud from the view of a cost analyst. Finally, I will conclude our work. Okay, let's begin. The 6th generation communication technique will be very trendy. From the figure, 3G to 4G, it took 10 years, and it took less than 10 years to develop from 4G to 5G. We believe that it will grow faster as 6G coming. However, privacy and the security issue will also be increasingly important, since the users are able to exchange a large volume of data in a short time. Due to the unique network isolation characteristic of private cloud, we believe it is a good solution for the privacy and security issue. To well establish or use a cloud service, cost analysis is important. If you are a cloud provider, you may always want to evaluate your profits in the cloud business. If you are a cloud user, you may always want to use the most cost-efficient cloud products. Hence, the total cost of ownership as a standard approach in analyzing the cost is a crucial topic for both provider and users. By definition, TCO in cloud computing involves all indirect and direct costs, such as costs of service provider purchasing, deploying, operating and maintaining assets, and the cost of cloud user renting clouds or purchasing the cloud's resources. The cost analysis and optimization methods for public cloud and hybrid clouds have been well investigated. However, there is too little work devoted into the cost analysis associated with private clouds. In our work, we surveyed the literature on public cloud TCO analysis methods and the optimization solution that minimize the TCO of a cloud service. Later, we will compare and contrast the similarity and differences between public and private clouds, and provide an in-depth discussion on what else can be further optimized to accomplish a lower TCO in a private cloud. Before we enter TCO in cloud computing, I would like to give a brief history about TCO. TCO was first being studied in business domain by Aaron since 1993. She claimed that TCO modeling is constructive for business procurement, decision-making, ongoing supplier management, and understanding of the indirect cost. As the IT industry rising in 2004, field scholars began to study TCO in the information technology domain. They have worked on topics such as revenue analysis in IT by taking the advantage of TCO. TCO in cloud computing was not studied until 2009 by Lee et al. They built a cloud cost amortization model to make it possible to calculate the direct and indirect costs of cloud computing infrastructure. Later, scholars began to pay much more attention to TCO research in cloud computing. In order to give you a better comprehension on the landscape of cloud computing TCO research, we classified the surveyed paper into two groups. The first group is model and tools for cloud TCO, where this paper are focused on how to measure the total cost in cloud computing. We further classified them based on whether the model and tools is for cloud provider or for cloud users. The second group is cost optimization, where people focus on reducing the total cost by solving some optimization problems. We summarize this work into three categories: task scheduling, resource scheduling, and heterogeneous computing. Now, I will talk about our survey on cloud TCO. Let's begin in up-to-down order. TCO models and tools can help cloud providers better understand their capital consumption, and thus it will be useful for revenue estimation, investment risk analysis, and decision making. Some researchers showed the overall cost measurements. They provided a full set of cost measurement model for cloud providers, including server cost, software cost, network cost, support and maintenance cost, power cost, cooling cost, facility cost, and real estate costs. In 2009, Lee et al. As the pioneers first solved the problem that the lack of a method to measure TCO. Lee proposed a cloud cost amortization model to calculate the total cost and further use the model to find the cost of running virtual machines. Later, research studied cloud TCO breakdown under different business models. In 2005, Filippo et al. Applied the system method to reorganize each part of the total cost. They regard each type of cost as a subsystem of cloud computing, and they illustrated a cost modeling framework for each subsystem. In 2016, Similarity et al. Demonstrated an overall cost modeling method for distributed cloud computing. However, they somehow either overlooked some detailed cost measurement or overlooked the cost calculation under some specific business domain. Thus, some research put eyes on the detailed cost measurements. In 2011, Mercer et al. Demonstrated a cost model for software development in cloud computing. In 2013, Sun and Lee illustrated a labor cost model to calculate the labor efforts in a service immigration scenario. They qualified the scale level of employees and built a probabilistic model to estimate the number of persons needed. Amana et al. Proposed analyzing method for cloud provider to make a better decision. Their method helps provider determine whether to replace aged service or not. Let's continue. Both the two works consider the cost modeling on the 99% system availability, since service level agreement and quality of service are important in the real industry. The next 3 paper focus on the real-time cost modeling. They introduce time dimension into the cost model. Thus, cloud provider can generate flexible strategy by analyzing per hour cost. Moreover, by interacting with modern machine learning and deep learning techniques, this kind of research can even predict the future cost. An investigation indicates that the energy cost accounts for 42% of all costs per month in a data center. Thus, many researchers presented models and tools for only the energy cost. In 2010, Yu and Bahati first showed the tools that measure the energy consumption in a data center, which is called scalable energy monitor architecture. Altrichakos and Chen's work dug a little bit deeper. They considered the energy cost as 2 parts, static and non-static, which made the model more flexible. In 2018, the power management model is proposed to measure the energy cost and schedule the power. In this work, the author used the advanced nonlinear autoaggressive network to develop a forecasting algorithm. The TCO models and tools for cloud users are mainly about helping cloud users such as small enterprise and startups to measure the cost of using cloud service, to compare different cloud products, and to decide the deployment strategy. We already know users can save much by using a cloud service compared with building a data set themselves. It is also important to let users know how much they can save to reach a successful business. In 2012, Martens et al. First contributed to the TCO measurements for cloud users. They summarized cost variables that considered by cloud users when renting cloud service, and proposed a cost model for infrastructure as service, platform as service, and software as service. Later, some researchers focused on developing tools and models to compare different cloud providers to estimate resource required and to further provide an optimal leasing plan. Then we finish our review on TCO models and tools. Only getting the total cost measured is not enough for sustaining a thriving business in enterprise. After knowing how to measure the cost, the next step is to find methods to optimize it, to reduce the cost to reach a maximum profit. We surveyed and summarized several representative papers from the aspects of task scheduling, resource scheduling, and heterogeneous computing. In a modern data center, there are thousands of millions of concurrent tasks and requests. If one can optimally schedule these tasks, it will reduce the system latency and increase the service quality. Pandey et al. Use a practical swarm-based hierarchical method to minimize the cost of task execution and further reduce the operation cost of the TCO. Similarly, the D-Cloud architecture is responsible for scheduling users' data requests to increase the system efficiency. In public cloud, elastic computing is used for resource scheduling, while resource scheduling strategy is still an active research direction. Some researchers propose the optimal resource scheduling strategy to optimize the TCO. For example, Wu et al. Demonstrated an optimization model to schedule resource in SaaS, and Mao et al. Lowered the cost by scheduling various types of virtual machines as resources. As for heterogeneous computing, this category is related to hybrid cloud, since some jobs can be executed as one part locally and the other part remotely. Some researchers started to look at methods that reduce the cost by optimally allocating the workload or task quota for local and external resources. These three works are all related to this. Finally, we finish our survey. Through our survey, most of them are related to cost modeling and optimization methods in public or hybrid clouds, while private cloud is seldomly mentioned. Next, we hope that by comparing and contrasting the public and private cloud environments, audience can draw a better understanding of the differences and similarities between public and private cloud, thus better understand the TCO of private cloud and possible ways that can be attempted to optimize the cost. We summarized the comparison in this table. Both public and private cloud can provide IaaS, PaaS, and SaaS service, but they have significant difference in the other 9 areas. The users of private cloud services are large organizations, community and enterprises, such as government departments, where the users of public clouds are general public users, small companies and startups. In general, the use cost is high for private cloud users because they need to purchase a complete cloud computing infrastructure, where the use cost is low for public cloud users because they only need to pay for the rental service in on-demand prices. Coins has two sides. High costs usually are accompanied by stable cloud service quality and high data security. Since the private cloud is deployed in the user's data center, the users can have an isolated network built within the domain of an intranet. Meanwhile, data security is guaranteed because users can manage the system and data by themselves. In contrast, since the public cloud is deployed in the data center of the service provider, the quality of the service often depends on the network quality between the user side and the public cloud data center. There is also a hidden risk of data leakage by side-channel attacks because public cloud users do not know where their data is physically stored. For the rest of the characteristics, I will discuss them from the cloud provider's perspective and the cloud user's perspective. We first discuss the difference between public and private cloud from cloud provider's perspective. As for procurement, it is hard for public provider to predict the exact user demands, so they need to adopt high-performance computing service, implement scalable storage, and network to meet the increasing demand. On the other hand, private cloud can get their customer requirements directly from their customers, so the demands are more predictable than public cloud. However, to better meet each customer's business objects, each private cloud data center has to be customized in a certain level. This customization leads to a huge personnel cost for the provider. In terms of maintenance, private cloud providers need to offer on-site support, which also increases the cost of owning a cloud data center. Therefore, compared with public cloud providers, a more flexible planning tools and automated deployment and maintenance tools are crucial for private cloud provider. When performing the resource scheduling strategy, public cloud benefits from the existing virtualization, multi-tenant, and elastic computing technology, while due to the high customization of the private cloud, the resource scheduling strategy becomes even crucial, since any waste of the resource will reflect directly on the customer bill. From cloud users' perspective, we discuss the differences and similarities between public and private cloud. As mentioned before, Private cloud and public cloud have similar usage in IaaS, PaaS, and SaaS. However, due to the high customization in private cloud, the users may need to work harder if they choose to develop their own PaaS and SaaS applications. From the perspective of operation and maintenance, public cloud users need to have certain operation and maintenance knowledge. For private cloud users, there are usually professionals from the private cloud provider side to sustain the basic operation and maintenance, which greatly reduce the cost of learning and training professions. As for the cloud evaluation, due to the different charging standards, the choice of cloud service directly affects the cost of users' investments. For public cloud users, there are some tools to help them choose the service provider and the rental solution, such as papers we surveyed before. However, there are no tools for private cloud users to show a comparison between providers. This is not a trivial problem because private cloud users need to compare private cloud service based on the investment cost, business value, security and stability, and IT cost saving. Thus, we call for people taking care of this site. To sum up, nowadays cloud computing is widely adopted for personal or organization use. How to help users and providers better understand their cost of owning a cloud service so that they can further optimize their usage or way to build the service to lower the overall TCO has become the next question. In this work, by discussing the similarity and the differences between the public and private clouds, we hope to shed a light on the unique points that people can take a look at for TCO optimization of private cloud. This is the end of my presentation. Thank you for listening.
Hi everyone, I'm Jiayi Huang from South China University of Technology. Today my presentation is the system-level performance analysis in 3D John mobile networks. My presentation divided into 5 parts, including introduction, system mode and problem formulation, proposed framework, simulation results, and conclusions. As we all know, there is potential growth of wireless data slice driven by smart devices has triggered the investigation of existing terrestrial networks in the era of the Internet of Things. However, it is a crucial task to satisfy the data slice under the circumstances of larger gatherings and natural or man-made disasters, such as the sport games, concert, floods, and earthquakes. These disasters are extremely harmful and unpredictable, which has a severe implication in terms of both economic and ecological costs. The quick communication recovery capability is a vital component for disaster relief and response. However, the conventional cellular communication systems are difficult to provide stable and reliable network connectivity. In the past few years, drone technology like payload capacity, longer average flight time has matured, and widely used in smart city construction, such as security monitoring, real-time video streaming. The drone can be quickly deployed by carrying a wireless communication module to form a drone eye base station, thereby alleviate the network congestion in hotspots. Drones open up the possibility for rapid restoration of damaged cellular systems. The UAV-assisted cellular network is considered a prominent solution for enhancing or recovering terrestrial cellular networks, which has attracted great attention in both academics and industry recently. Therefore, the 5G communication systems also considers the application of the low-altitude zones in the system, but it still has many challenges for larger-scale application. The stochastic geometric theory is a method widely used in wireless network performance analysis because it can well capture the connection distance and the randomness between nodes. And in our paper, we also use the stochastic geometric theory to obtain the performance boundaries of joint cellular networks. In contrast to prior literature on joint communication system analysis based on stochastic geometric theories, we propose the uniformly disposed 3D Brownian and deterministic motion modes for joint cellular network. We combine these three modes to explore the performance bounds of actual joint cellular networks. And then we provide a system-level analysis of joint cellular networks and obtain close expression of line-of-sight and non-line-of-sight propagation. The simulation results demonstrate that the significant performance gains can be achieved by the proposed framework. This figure illustrates the mode of the 3D joint cellular networks. In our paper, we assume the typical user locating and origins, and the total number of the joints in this 3D space follow the person per process, that is the so-called PPP. After we obtain the total number of the joints in this 3D space, we display them according to the uniformity distribution. After the joints connect with the typical user according to the cellular association strategies, the sovereign joint will move according to the 3D Brownian motion mode or deterministic motion mode or stationary mode. The main indicators in our paper is the average rate of the typical user. The formula is E log 1 plus SINR. The path loss function is defined as the second formula in this page. Where R is the distance between the typical user and the sovereign joint. Beta 0 is the minimized clipping loss. Beta 1 is the constant parameters of the path loss function, and alpha is the path loss exponent. Because all channels undergo free space path loss, so the alpha equal 2. The next formula is the probability of the loss propagation. From this formula, we can find that if the distance between the typical user and the sovereign joint is between 0 and d, that is the loss propagation. If the distance between typical user and the sovereign joints is between d and r, that is the non-loss propagation. If we want to calculate the average rate, we should first calculate the Laplace transform of the aggregate interference under loss or the non-loss propagation. Then use this LT, we can obtain the CDF of the SINR. That is the altitude of the probability. Using these three formulas, we can obtain the average rate. As we all know, the actual joint motion mode is Markov motion mode, but it is too complex to analyze. Hence, it is uncheckable to tag directly. So in our paper, we construct uniformly disposed 3D Brownian motion and deterministic motion mode to explore the performance boundaries of actually joined cellular networks. This can make this problem become easy. About the uniformly disposed mode, as we talked before, the cellular association strategies is the greatest receiver SINR. Due to the all channels undergo free space path loss. So the cellular association strategies is the closest distance between the typical user and the join. After obtain the SINR between the typical user and the sovereign join, we can obtain the CDF of the distance between typical user and the sovereign join under loss or no-loss condition by using the characteristic of the uniformly distribution. After obtain the CDF of the distance, we can obtain the PDF of the distance between typical user and the sovereign join, and use the PDF of the distance, we can calculate the average rate. That is very important when we calculate the average rate. After the sovereign join build a connection with the origin user, the sovereign join will move according to the 3D Brownian motion mode or deterministic motion mode. If the sovereign join according to the 3D Brownian motion mode, we can use the stochastic differential equation to capture the movement of the sovereign join. That is the fourth formula in this page. And then we also can obtain the CDF of the distance between the typical user and the sovereign join under loss or no-loss condition. The methods are similar to the uniformly disposed mode. If the sovereign join according to the deterministic motion mode to move, the corresponding distance with respect to the origins is the first formula in this page. And also we can obtain the CDF of the distance between typical user and the sovereign join under loss or no-loss condition. Then we can use to calculate the average rate. This part is the simulation resource. In the right, we can see the parameters and values in our simulation, and we use Monte Carlo methods to do the simulation. This figure illustrates the spectral efficiencies against the different number of the tuners. From these figures, we can find that if the number of tuners increase, the spectral efficiency also increase. And the most important thing is that the Brownian motion mode is the lower bound of the performance, and the deterministic motion mode is the upper bound of the performance. And in the actually use, if you want to increase the spectral efficiencies, we can increase the number of tuners to satisfy the performance requirement. This figure illustrates the Nakagami fitting impact on spectral efficiencies. Also, we can find that the Brownian motion mode is the lower bound, and the deterministic motion mode is the upper bound. This figure illustrates the joint velocity impact on spectral efficiencies. From this figure, we can find that when the sovereign joint velocity increases, the average of the spectral efficiency of deterministic motion mode and the 3D Brownian motion modes is also increased. That means that if we want to increase the spectrum efficiencies in the actual John cellular networks, we can increase the sovereign John velocity. But we should also pay attention to the safety and the policy restrict. In these figures, we can find the sovereign John deployment density impact on the spectrum efficiencies. And we can find that the best deployment density may be around 3. In this paper, we explore the performance of actual John cellular networks using these 3 modes. And the stochastic geometric theory is applied to obtain the closed expression of the John cellular network. After combining these 3 modes, we can avoid directly using Markov motion mode. Finally, the simulation results confirm the performance gains of the proposed framework. Compared to some other analyzed modes, the significant performance gains can be achieved by considering 3D Brownian motion mode and the deterministic motion mode with stochastic geometric theory. That is the part of Q&A. Thank you.
Good afternoon, everyone. My name is Luo Jingci. I'm from South China University of Technology. I'm very pleased to be here to report on my paper. The topic of my presentation is GN power allocation and splitting control in SWIFT-Aided multi-carrier NOMA system. My presentation will include these 5 parts. First, the introduction of our paper. Second, the system model and the problem formulation. Third, the proposed algorithm. Fourth, the simulation results. And in the last part, the conclusion of this paper. In the first part, we'll make a brief introduction of our paper. With the rapid development of the 5th generation and its advanced application scenarios, the limited spectrum and energy resources are increasingly difficult to meet the requirements for the communication system. Hence, it is considerably significant to improve the spectrum efficiency and the energy efficiency. The NOMA scheme has been considered as a significant technique to achieve a higher spectrum efficiency for the 5th generation and the future communication systems due to the elimination of the channel orthogonality. On the other hand, the SWIFT technology is able to collect energy and receive information parallelly. And it is viewed as an energy efficient solution to the green communication system. However, most of the existing work consider the single carrier NOMA systems, and the performance of the SWIFT-Aided MC NOMA is still an open topic. Motivated by this, we consider a normal system which combines the spectrum efficient MC NOMA and the energy efficient SWIFT. The system we consider is shown in this figure. In the transmitting side, there is one base station, and in the receiving side, there are K mobile users, which apply the power splitting scheme to realize SWIFT. All the transceivers are equipped with a single antenna, and the available bandwidth of the system is divided into n orthogonal subchannels, and the base station communicates with K mobile users through these all subchannels. Based on this system model, for the case user on the nth subchannel, the received signal for information decoding and the energy harvesting can be respectively given by these two expressions. Furthermore, the interference can be written as this expression, and hence the signal to interference plus noise ratio and the available data rate can be respectively given by these two expressions. On the other hand, the harvested energy can be given by this expression, and accordingly, for the case user, the achievable data rate and the available harvested energy can be calculated by these two expressions respectively. And the total throughput of the considered system can be given as this expression. Based on the above analysis, the total throughput maximization problem for our considered system can be formulated as follows. The objective function of this maximization problem is the total throughput of the system. The optimized variables include power splitting control and power allocation. And the constraints include the range of the variables, the minimal requirements of the harvested energy of its user, and the maximal power supply of the base station. It is evident that this maximization problem is non-convex due to the couple variables and the multi-user interference, and hence it's very difficult to be solved directly. And therefore, we propose a dual-layer iterative approach to jointly optimizing power allocation and power splitting control. In the inner layer, we focus on optimizing the power splitting control and the fixed power allocation, and hence the original problem can be simplified as the subproblem P1. It can be proven that the subproblem P1 is strictly convex with regard to the power splitting control role, and hence this subproblem can be solved by using the Lagrange duality method. In particular, the Lagrange function and the Lagrange dual problem can be given by these two expressions respectively. The Lagrange dual method includes two steps. In the first step, we update the power splitting control law with the given dual variables by using gradient ascent method. And these two parameters respectively denote the gradient direction of the Lagrange function regarding to law k and the best updating state. Then in the second step, we update dual variables with the optimized power splitting control load by the typical binary search method, in which the subgradient of the Lagrange dual function with respect to the dual variables can be given by these expressions. Then in the outer layer, we aim at optimizing the power allocation under the fixed power splitting control. And accordingly, the original optimization problem can be simplified as subproblem P2. Similarly, it can be proven that the subproblem P2 is convex with respect to the power allocation. And hence, this subproblem can be solved by using Lagrange duality method too. Up to now, the optimization of power splitting control and power allocation have been given in the inner layer and the outer layer respectively. Now we developed a complete solution for the original problem, which is summarized in this table. And then numerical results are provided to evaluate the convergence performance of our proposed approach and the superiority of our considered NOMA system with the application of PS with a PS-based SWIFT in terms of throughput. As shown in this figure, it is evident that the proposed approach is gradually converged to the optimal value, which acquired by the extractive search algorithm. And this confirms our convergence analysis. And in this figure, we examine the performance comparison in terms of total throughput among our considered system and other system scans. As shown in this figure, the NOMA scans are more spectrum efficient than the conventional OMA scan. And more importantly, our considered system outperforms either the TS-based MC NOMA or the PS-based SC NOMA. This result demonstrates the superiority of our developed joint power allocation and splitting approach for the considered MC NOMA system with the application of PS-based SWIFT. And accordingly, it provides a significant direction for practical communication system design. Finally, we made a conclusion of our paper. In this work, we have studied the total loop maximization problem for the Darling and NOMA system with the application of PS-based SWIFT under the constraints of the maximal transmit power supply and the minimal demand for EH. To solve this non-convex optimization problem, we propose a dual-layer iterative approach. The corresponding subproblems in the inner layer and the outer layer were solved by employing the Lagrange duality-based method. And finally, simulation results verify the theoretical analysis of the convergence performance and confirms the superiority of the proposed algorithm for our considered system to other systems, including the TS-based NOMA, the PS-based NOMA, and the PS-based OMA schemes. And the results provides a significant direction for practical communication system designs. The above is my presentation. Thank you very much.
The development of smart home disaster prevention system to improve the living quality of life. We can building smart home with Internet of Things IoT technology. It can bring in residing living combination. In this article residing in this article using the representing PI to building a smart home disaster prevention system. This article using various systems such as flame sensor to monitor vehicle dangerous in the home to avoiding first. The system function purpose in this article are 1. Release time monitoring of home intervention and safety use. 2. Indoor temperature and humidity sensors. 3. Port temperature and humidity sensors. 4. Disaster detection. 5. Fish tank water level detection. The portable meter help to provide a comfortable home. Information it also reduce the damage caused by home disaster. Use can check the chain of the home inventory through the portables, plan from which help to object the energy saving appealing in the home. Smart houses are based on the technology of the IoT writing network and the internet. It can control large windows, temperatures, and humidity. Arduino values. It clothing and home believe it can filter morning information factor in the home. These factors are creating out the event and creating. According to the any less the house information can be controlled at the automation technique and temperate and humidity. Humidity rule to home a pretty country. Smart home system can monitor the use of home. A previous in the house for power control. As agents size count, smart home also need to be included in disaster prevention monitoring, such as kitchen, smoke, temperature, 点 etc. to answer that early people forget to turn off the fire suppress to catch a fire when cooking. Many families now have fish frying or pot plants, and the smart home also need to morning fish. Then morning fish tank and the portal plants. System model. The popular system containing the equipment to Bluetooth and the relays, and the country and the country and IoT information with writing network. The main function of this article are indoor temperature and humidity detention, 那个 water permit, bromel gas control single and fish tank remind for a dead water. The system probable in this article is based on normal system. Therefore, the price is recent and easy to deploy the system. In addition, the system can detect whether there is a disaster source at the mail gas, country tracks, signage, and family sensor to ensure the safety and the life of the family quality. Create a database. Live in the data of tempo, turn, and humidity sensor. Rewriting the data of the flame sensor. 那这是flame detention 是 align and terminate rewrite the data of gas sensor 是 gas detention 是 align and terminate rewrite the data of the water level sensor relieve the data of the solid moisture sensor 是 return data. The air clear media use Bluetooth and relays to control home apply. The functions are 1. Ready time monitoring of house information and safety is used. 2. Indoor temperature and humidity science. 3. Port temperature and humidity science. 4. Disaster detention. 5. Fish tank water level detention. The temperature and humidity sensor are installed in the system. If the temperature and humidity are high, then the household apparently they can adjust the temperature and the humidity will be activated. The fish tank is equipped with a water level sensor. When the water level is low than the stand, it will send a participant message to inform the user that water need to be deep. The method in this article mainly use the party sensor, which can mainly populate the system in various households. The development process of this article is shown in Figure 1. There are the probable system development and the tests as shown in Figure 2 to 5. Figure 2 is the information values. Figure 3 is the blue radius. Figure 4 is the remote control. Figure 5 is the pace test. The system purpose in the activity already has temperature and humidity, flame, gas, and other sensor. Information monitor, monitoring of home and integration of mobile device makes the system mounting more entails. In addition, we also come Chinese voice Chinese system that use enable more function choice to provide the safe mounting for the home environment. The system provided in this article is mainly based on parity in the foot. The system will be particular and can be installed into various households. Thank you for your listen. On the security, police and provides protection in election health information system. The integration of information technology and medical techniques could be found expanding the time and location for medical service, as well as provide better medical quality. That it has become a trend in medical domain. For this reason, this study purpose to develop and integrate healthcare information system. For learn more, based on your price and system information security, the key in a smart nation health insurance card or a paintings fingerprint together 那个 fingerprint together with a data group singular and the public key are unity then for retrieving aircraft medical record from the system so as to protocol the confined information in the system and granting paintings prices. This system cover other relevant function of medical record, mobile data link, information security, protection, and draw conflict avoiding in the integrated healthcare information system. A painting private could be protect the hiding. The real location of medical record is always the same that doctor from different hospital could access to the medical record the hospitalization when dealing with and upgrade case. The ready time medical record retrieve infinity and the recover rate. The information in the system per calendar body cover the margin of painting, insurance claim, and draw calling in order to prevent data from principal world medical. Avoid the troublesome of insurance claim application and reduce paintings problem about collision respect, and integrate medical information system should be a serious convenient and complete system with flowing justice, possibility of recount medical record. Patient's recent medical record are logged in the health insurance IC card with automation data could read the patient's medical information in other medical intermediate and repeat as the patient medical history to promptly make control. This going it one in answer data discerning confidence and efficacy. Medical quarantine function. The functions stress on the combination for painting current medical and a grant in ID and automation information are integrated with the medical information system and resulting in the patient's health insurance IC card. When the patient is not able or busy to quote medical by himself or herself, especially the one will prescribe or material disability or with difficult in moving could enter a ledge. A green source hosting machine to cool medicine. Link bleed and price protocol. Any media party and data use phase one in an integrated medical information system. Painting immediate link brief. Mary the health insurance report using could as a printing real identity. From mass linkability to painting indeed is simple. The holder of hierarchical perception, but not the really identity. Linkability and price potential. Data identity linkability marries spicing just medical action could grab a data really identity the linkability of both of nation health instruct to data identity is simple. The person price point writing, but now the really identity. Indeed. No, now link belief or data indeed. I did. Page max could not link a data in deity from electron position point. Avoiding paintings, pension, with plenty medical code. After the completion phase, electron, health science, and technology has access to electron per schedule might be early. Then to wide per schedule to avoid a pension respiratory could medical in defined per schedule with the copy of electron per schedule to result in medical results worst. A hero integrated medical information system should present the function to prevent such similar behaviors. A integrated medical information system with secure policy and prevents particle which companies patents record pointing modify smart card and fingerprinting induce finding system and applies policy single and group signature is purpose in this study. Thank you for your listen.
Hello professors, now I will give a speech for our paper. The title of our paper is Research on Detection Method of Malicious Node Based on Flood Attack in VANET. Our paper has 5 keywords. They are VANET Security, 5th Generation, Flood Attack, TCP/SYN Flood, UDP Traffic Flood. We have 3 authors. The first author is Guizani. He is from Beijing University of Post and Telecommunications. The second author is Li Yuan from Southwest University of Science and Technology. The third author is Wang Yongjian, who comes from the National Internet Emergency Center. My speech is mainly explained based on the following 6 points: abstract, introduction, related work, principles and methods, detection method. Conclusion. The structure of my speech content is basically similar to the organizational structure of the thesis. First of all, let's get to know what is VANET. The VANET is an intelligent system born from the application of the Internet of Things in the transportation system. It is an integrated application and and extension of related technologies such as computers, internet, mobile communication networks, and the Internet of Things. It completes the information interaction between vehicles, roads, and traffic control centers. For example, if an vehicle faults, it sends a fault alarm to other vehicles and on the road through the VANET, and at the same time, the traffic control center sends fault information. VANET can make road traffic more intelligent. However, it is based on the TCP and UDP network protocol, and there is a risk of being attacked. Many including TCP SYN flood attacks and UDP traffic attacks. I will explain the principles and defense methods of those two attacks in detail later. In this page, I mainly explain the composition of the VANET and introduce the two floating principles of TCP and UDP. The VANET mainly has the following four kinds of communication, which are the communication between the vehicle and the cloud, the exchange of road traffic information between the vehicle and the cloud. The communication between vehicles and is mainly the information interaction between the vehicle and the surrounding vehicles, which is short-range communication. The communication between the vehicle and the roadside infrastructure is mainly the information interaction between the vehicle and the RSU. The communication between the vehicle and the person is mainly the information interaction between the user and the vehicle through the cloud platform. Then the TCP/SYN flood, the attacker used to quickly initiate a large number of TCP/SYN collection requests in a short period of time, causing the RSU to be too late to respond, thereby consuming a large amount of RSU computing processing until denial of service. UDP traffic fraud. Malicious nodes will frequently send UDP data packets to other nodes. The destination addresses of the data packets are the RSU. A large number of packets occupy network bandwidth, storage, and RSU computing processing power in a short time. In this page, I mainly explain the VANET security, vehicle security attack cases, and attack defense methods in recent years. In 2010, researchers attacked the tire pressure monitoring system of the cars. In 2013, a hacker attacked the control system to control the vehicle's driving. In 2015, researchers attacked the Jeep Cherokee's Uconnect. In 2017, Nissan's financial company database information was stolen by hackers. VANET security issues are emerging one after another, and the researchers are also working on attack defense methods. The TCP/SYN flood and the UDP traffic flood defense methods are mainly packet detection, IP detection, and traffic detection. Now I want to explain the triple handshake mechanism of TCP collection establishment. When the client requests to connect to the server, it first sends a SYN request packet. The server replies with a SYN ACK after receiving the SYN packet, and then the client replies with a server ACK packet after receiving this packet to complete the TCP collection. In the first picture, it shows the principles of the TCP/SYN flood. The attacker used the defect of the TCP collection mechanism on the previous page to initiate a TCP/SYN flood. Attackers frequently send SYN requests to the server, but do not respond to the server with the SYN ACK packets, resulting in an increase in the number of TCP half connections on the server and exhausting server resources. In the second picture, it shows the principles of UDP traffic flood. The attacker sends a large number of UDP packets to the victim through other vehicle nodes in the VANET, resulting in a rapid increase in network traffic and exhausting the victim's computing processing resources, resulting in denial of service. This is the detection method of TCP/SYN flood. In this picture, we can see in response to TCP/SYN flooding attack, this paper uses the node ID restriction method to detect and defense. When the RSU sends network access requests for the same ID multiple times in a short time, it limits the number of network access requests for the node. And RSU shortens the TCP half collection timeout period and closes the request connection initiated by repeated ID. This is the detection method of UDP traffic flood. In this picture, we can see adapt RSU to monitor the data flow of nodes in network in real time for UDP traffic flood. The RSU counts the data traffic of each node and calculates the average traffic volume according to the time period respectively. In the average data traffic volume of a node is higher within a certain period of time, the node can be deemed to initiate a flood attack, and we can limit it. This is conclusion. Two types of flood attacks in this paper also have limitations. The detection method for the TCP/SYN flood attack will be affected by the network changes. The average traffic in the detection method for UDP flood attacks will be affected by fifth-generation network conditions, and the detection performance of both will be affected by mobility of the vehicles. When multiple nodes attack at the same time, the detection effect may not be ideal. So this is my speech of our paper. Thanks for watching and listening.
Hello everyone, my name is Yu Jiang from Wuhan University. It's my pleasure to share our researches in EAI 6GN 2020. Our topic mainly about the simulation method of 5G location. First, let's see the background of 5G positioning. In recent years, the development of the 5th generation mobile communication system is in full swing. To meet the needs of 5G, many new technologies and features have been introduced, such as millimeter wave, massive MIMO, ultra-dense network, and device-to-device. These technologies can solve communication problems and also provide a lot of key features required for positioning. As global navigation satellite system is hard to apply to indoor environment, and the database of fingerprints used in Wi-Fi and Bluetooth positioning are difficult to build. 5G positioning is expected to achieve both accuracy and convenience, and realize indoor and outdoor seamless navigation and positioning. Next, we will give a brief review of 5G positioning. Positioning is quite complex because there are a lot of problems to be solved, and the research of 5G positioning also has many categories, such as frequency selection, waveform designing, channel modeling, and interference study. We see that most of the articles are verified by simulation, and the simulation is an important research method when 5G base stations and devices are not popular. However, few articles focus on the construction of 5G simulation environment. So we studied the system architecture of 5G positioning and proposed a small simulation experiment scheme. It may be a reference for researchers, and we wish it can help people who are interested in 5G positioning but don't know how to start. And these are our contributions. We improved the mature channel simulator from the perspective of positioning. Our scheme has rich parameter settings, making it convenient to study the impact of different factors on the positioning. The scheme introduced a map of real world and will play a guiding role when deploying base stations. And the scheme is able to learn from the rich research results in GNSS field to solve 5G positioning problems. Then I will introduce our system model. First, look at the flowchart of 5G positioning proposed in our paper. The source was inspired by the works of Pivisto et al. First, the user moves in uniform motion along a certain track in a certain seat, and make a position request at regular intervals, and it simulates in this block. And then the channel simulator simulates the signal propagation process and gives the observations. That is the time of arrival and the angle of departure. And then the estimate positioning program estimates the user's position and sends it to the users. According to the above process, the simulation platform of 5G positioning can be divided into 3 parts: scene generation, signal propagation simulation, and position estimation. The implementation steps are discussed below. The theme for positioning is the basis of simulation experiment. Both reality and complexity need to be considered in scene generation, and we mainly refer to the simulation guide provided by METIS. Two methods are taken to generate scene in this paper. One is to generate scene randomly by the program, and just like this. And the other is to import data from open source maps, such as OpenStreetMap, with appropriate modification, like this. Specifically, 4 elements are necessary for a scene. That is the buildings, the base stations, roads, and the trajectories. We generate these 4 elements one by one, and it will describe in detail next. We use the open source map as example. The open source map that contains the building information and the topological information of roads are stored in extensive markup language format. We use Python scripts to praise it and reproduce the buildings and the roads, just like these 2 pictures. And then base stations need to be generated. Combining the reality and the simplification, we assume that the base stations are randomly distributed on the edge of the buildings. And according to the conclusion in others' research, the user can perform line-of-sight communication with base station in 80% when the base station intervals are not more than 50 meters. And we use this as a basis to deploy the base stations, and the result is shown as this picture. The trajectory generated in this paper is based on load network, and it includes 2 generation rules. First, when it comes across the intersections, it will randomly turn to the other 3 directions, but cannot return the way it came from. The second is that the trajectory is considered to be over after 6 turns, or when it goes out of the map. And the result is like this. The generation of random map is just similar. We just need to design a new method to generate the topological relationship between the nodes automatically. Now we will introduce how to simulate signal propagation. The channel model plays an important role in 5G positioning, for it contains geometric relationship and the propagation information between the observed value and the position, and it can be used to derive positioning algorithms and analyze the positioning performance. And the common used channel models include METIS, Winner2, and related models of 3GPP. And it is worth mentioning that Rappaport, TS et al. Proposed a new channel model of 5G based on large number of actual measurements, and they developed an open-source channel simulator. We use it to simulate signal propagation. And this is the interface of the simulator. The simulation process is automatically completed by the program after the parameters are manually set. The input parameters are mainly used for channel and antenna settings. As shown in the figure, there are many parameters can be set. The simulator conducts signal propagation simulation in 12 steps, as shown in the figure, and it finally gives the key values required for channel modeling. The propagation delay and the angle of departure are gradually generated during the simulation process, and they are the observations required for positioning. But the distance and angle of signal propagation are randomly generated by the simulator. while the positional relationship between the users and the base stations are fixed. To solve this problem, we calculate the geometrical relationship between the users and the base stations at each checkpoint, and then put them as parameters into the channel simulator. After that, the random generation of the channel simulator is changed to a semi-random generation based on the input parameters, and we can get a truly observation. By solving the observation equations, can obtain the position estimation, and this is the linearized equation, where Zik is the observation at the ith base station at time k, and the Hik is the linearized Jacobi matrix, and Ci0k is the approximate value of the observations, and Xik is the difference between approximate value and the true position. The least square method is used to solve it, and it is often difficult to meet the accuracy requirement by performing least square method only once. It is generally necessary to improve the accuracy by an iterative method, and we use the estimated result as the approximate value to start the iterative. The 5G simulation environment can be built up based on the previous section. However, it needs to be verified whether it is effective or it can support further research. For this purpose, some important factors that will influence the position effects are found out. These factors are used in experiments as a variable, and we test the environment by observing whether the result changes as expected or not. In this experiment, we test the simulation environment ability of simulating the impact of the number of base stations on positioning effect. These are the settings of the experiment. The number of base stations used for positioning grow from 1 to 4, and the positioning effect of different number of base stations are shown in the figure. The positioning accuracy is about 2 meters when the number of base stations are 1 to 2, and it is about 0.1 meters when the number of the base stations are 3 and 4. It can be seen that, cause the introduce of the angles, only one base station can do the locating, and the positioning accuracy changes significantly when the number of base stations increased from 2 to 3. In GNSS system, the geometrical distribution of satellites has a great impact on the results of positioning, and it may also have influence in 5G positioning. This experiment is used to test whether the environment can explore the influence of the geometric distribution of base stations. And this is the setting of the experiment. This is the origin distribution, and we add 2 base stations in the left and 2 in the right. The above are the positioning results of the origin one, and the below are the positioning results of the added one. It can be seen that the arrangement of base stations has great influence on the positioning accuracy, and supplementing a small number of base stations in key areas can greatly improve the effect of positioning, like these 2 areas. The simulation program in this paper can help find these key areas. The multipath effects still exist in 5G positioning, and this experiment is to test can it be studied through our simulation platform. The experiment results showed that the multipath and the fast path has the same p-dot but quite different positioning effects. The main reason is that the multipath introduces large measurement area, And multipath effects in 5G positioning still has a great influence on the effects of positioning. It is must to eliminate the impact of multipath in order to achieve high precision positioning. By choosing different line of sight or non-line of sight parameters can simulate signal propagation in both line of sight and non-line of sight environment. With this, the simulation environment of this paper may have ability in studying the influence of line of sight on the effects of positioning, and it is tested in this experiment. We see that the positioning error in non-line of sight condition is much larger than that in multipath effect, and the positioning error is expected to nearly 20 meters. So it is essential to ensure the line of sight in order to achieve high precision positioning. That is, a high-density base station network is the basis for high precision 5G positioning. Finally, let's do a conclusion. We have proposed a 5G positioning simulation experiment scheme and presented its flowchart. We have carried out a large number of experiments by changing the system setting. The ability of the simulation environment established in our paper has been verified. Certainly, there are still some shortcomings in our paper. These are the aspects we will study in the future. First, we only use the channel simulator on a relative risk level. We haven't fully utilized its powerful capability on simulation, and we haven't optimized the algorithm used for positioning either. And my presentation is finished. Thanks for listening.
Hello everyone, my name is Xueya Ru from Chongqing University of Posts and Telecommunications. The topic of my speech is hybrid duplex relay selection in cognitive radio network. Next, I will give a speech on my paper from the following 5 parts. The first part, the research background of this paper. Cognitive radio technology can effectively alleviate the current shortage of spectrum resources. The 4-duplex relay technology can simultaneously receive and transmit signals of the same frequency, thus improving spectrum utilization, increasing system capacity, and saving time slot. Each relay node's ability to help the source node improve the transmission quality and the interference cost to the primary user are different. The second part, the research motivation of this paper. Cognitive 4-duplex relay selection technology meets the needs of communication development. It's very meaningful to study how to effectively select the appropriate node as a communication relay. The exciting work doesn't involve the hybrid duplex mode switching problem of cognitive relay networks. Therefore, a hybrid duplex relay selection algorithm with low interference is proposed to maximize the sacrifice value of primary user, half or 4-duplex mode switching, and optimal relay selection. Based on the above research motivation, we analyze the spectrum sharing system model in underlying mode. As shown in the figure, the relay selection mode of cognitive relay contains the primary user network, secondary user network. In the communication process, the secondary user network must meet the maximum interference limit that the primary user can tolerate. That is, the interference temperature limit. The solid line presents the transmission link of the useful signal. The dotted line indicates the interference link in the system. In the cognitive relay network of underlying mode, the relay node can work in 2 modes of half-duplex and 4-duplex. The 2 modes will bring different gains to the capacity of the secondary user network. According to the AF and DF protocols, the system rates of the primary network and the secondary network when the relay node works in full or half-duplex are analyzed. First, 4-duplex mode. We can get the secondary user system rate and the primary user system rate. And we can know lambda CFD2I is the end-to-end signal-to interference and noise ratio of the secondary user network in cognitive full duplex relay, and lambda PP2I is the signal-to-noise ratio of the primary user network communication. Half-duplex model. We also can get the secondary user system rate and the primary user network rate. Utilite function. The utilite functions of model switching and relay selection that optimize the performance of the entire system, including the primary user network and the secondary user network, are defined as the advantage is that by combining the two, the joint performance of the primary network and the secondary network is comprehensively considered, and the problem of only considering the performance of the secondary network in the traditional relay selection method is avoided. Model switching. The size of self-interference is a key factor for model switching. It is foreseeable that the sufficient and necessary condition for full duplex model is better than half-duplex mode is that the signal-to-noise ratio of self-interference channel lambda II is lower than the critical point lambda IITH. According to the lemma 1, when the secondary relay network adopts the AF protocol, if 27 is established, the performance of the relay node is full duplex mode is better. Otherwise, the half duplex mode is adopted. According to lemma 2, when the secondary network adopts the DF protocol, if the formula 28 is established, the half-duplex mode is adopted. If the equation 29 is established, the full duplex model is adopted. Next is simulation results. In order to verify the performance of the model switching relay selection algorithm proposed in this paper for cognitive hybrid duplex networks, MATLAB was used to perform system-level simulation on the proposed algorithm. The main system simulation configuration parameters are shown in the table. The figure is shown that the relationship between self-interference and the secondary network system capacity under different duplex model and relay protocol. From this figure, we can know that when the half-duplex model is adopted, there is no self-interference at the relay node. And when the full duplex relay node is adopted, the system capacity of the secondary network decreases as the self-interference value increases. The abscissor's value corresponding to the intersection point of the curve is the critical value of model switching. This figure is the relationship between transmit power and system capacity under different algorithms and two protocols. From this figure, we can know that the algorithm proposed in this paper can be significantly improved the primary system capacity while slightly reducing or even enhancing the capacity of the secondary system with the comparing of the HDRS and FDRS algorithm based on MMRS criteria. The next figure is the relationship between the capacity of system and the number of candidate relays under two protocols. From this, we can know that the algorithm proposed in this paper can significantly improve the system capacity of primary user and improve the whole system capacity under the condition of slightly reducing the capacity of the secondary system. Sincerely, thank you for your listening.
Good evening. My name is Li Mei. I'm coming from Institute of Remote Sensing and GIS, Peking University. Very glad to see you. Today, the topic of my presentation is about a VR simulation system for coal mine safety based on cloud rendering and AI technology. The outline is introduction, problems and objectives, methods, results, and discussions, and conclusions. Coal mine, regarded as a high-risk industry, has a strong demand on virtual reality training environment for mine safety and emergency rescue. As we all know, it has unique advantage in mine safety training, emergency rescue training, mining and drifting producing process simulation, disaster simulation, and mechanical operation training, and so on. In the past 10 years, VR technology has improved mining training significantly on both the hardware side and the software side. However, there are still some problems such as expensive and uncomfortable hardware, lack of good user experience and intelligence design. So in this paper, a cloud virtual reality training system for underground coal mines is designed. The United States, Australia, and UK has used VR as training environment in the past 2 decades, such as University of Nottingham has a long history of developing and applying VR technology on coal mine safety training. In US, the National Institute for Occupational Safety and Health explored how the mining industry can effectively use serious games for mine fire escape training. In Australia, University of New South Wales developed iCinema, which is an immersive theater environment with more than 20 modules for improved teaching and learning for mining engineering education. You can see this is the Advanced Visualization and Interaction Environment. We call it AIM. It's coming from the University of New South Wales. It's a 3D VR theater that can host 30 visitors at any time and has a closing door that provides a full 360-degree image. This image is useful for quickly immerse a group of students in a virtual world. In China, university and large mining groups and the local government also apply VR hardware and software to safety training and emergency rescue training. Those VR systems provide the function of standalone version and Q&A safety-related training. The VR hardware includes a project-based panoramic display system, infrared training stereoscopes, glasses, VR headset, and display, pad, touchscreen, and other devices. Moreover, the desktop 3D visualization system is also very popular in coal mine. They have function of 3D geological model, ventilation simulation, real-time data monitoring and emergency response, and so on. But there are still some problems. In China, most VR training systems lack of good learning experience. That means those coal mine training systems has teaching and learning function, but only with single player mode and ask question pattern. There are no complex artificial intelligence man-machine interactions. So the VR advantage cannot be fully used. The second is VR software. It also needs to be gamified and intelligence. We all know the traditional VR training applications are facing the challenge from advanced technologies such as AI, 5G, cloud computing, and so on. So the gamification and online learning, or we call it e-learning, has become a tendency in the future education. Thirdly, the VR application needs to support various light terminals, such as PC, mobile phone, pad, headset, or so on, to have ability to own a mass multiplayer online and upgrade the question and answer learning pattern into a multiplayer game experience pattern. So our research objectives is to design and develop a serial game VR simulation platform by using cloud rendering and game AI technology. And we want to change the question-answer learning pattern into a serious multiple game experience. And also, we use AI technology to enhance users' experience of learning and to strengthen their memory and safety awareness. We can see from the left side, we give a interface of virtual reality training system for underground coal mine. We have 8 modular analysts, geology environment model, such as procedure of coal formation, geology condition, coal seam, and geology structure, geographic environment and surface plans, underground railway arrangement, mining area design and working phase design, and a coal mine production system such as ventilation, transportation, belt, lift, power supply, water supply, and drainages, coal mine blasting process and longwall mining process, coal mine disaster simulation, gas, water, roof falling, and fire, underground safety monitoring systems such as methane, wind speed, temperature, carbon dioxide, monoxide, self-rescue, and emergency response. This system uses a UE, we call it a real game engine from Impact Game Company. It includes a rendering engine, a physical engine, and it also uses blueprint scripting language, animation, and the game AI modular, networking, terrain, streaming, and so on. UE, or we call a real engine, is one of the best engines which has a complete suite of game development tools. Upon this engine, we designed a VR training system. In this research, we use 3 technologies: Regularity, 3D modeling, and AI behavior design. Let me introduce the first technology, Regularity. As we all know, the popular website 3D is HTML5 and WebGL, but right now we use cloud rendering technology, cloud rendering architecture. Mainly because it's not a special expensive requirement on the client. It allows the user to choose different platforms such as PC, laptop, tablet, and even smartphone. So we can see from the feature, the system is divided into 3 parts: portal server, client, and render server. As a portal server, it's responsible for users logging, finding the appropriate server according to the user's choice. As the render server is most important, it's responsible for processing the mouse and the keyboard input events from the client, translating and sending them into the interaction models of 3D program for the further pacing. The 3D sense images are captured, encoded, and sent to the client as a video streaming. So the totally difference is of cloud rendering is extend video streaming. The render server includes basic function model, game AI function model, and advanced function model. Client is responsible for displaying the received 3D sense streaming and send the user input such as keyboard and mouse event to the server. We also use 3D Max or Maya to build a 3D sense of the underground and the surface. We import the 3D model to the real UE editors. The materials is as a paint applied to the model, so we applied a series of material tools to apply the 3D model material such as normal map, diffusion map, mental map, texture map. We also sent satellite to light our scenes. We build a 3D geology model and underground landway models from CED or GIS file automatically. We use the blueprint scripting language to program actors, animation, and AI behavior. Very important of our research we designed AI behavior tree. Game AI, we call, is a model of 3D engine. Game AI refers to the virtual man, or we call it non-playing character, NPC, controlled by the computer, who can simulate the intelligent behavior of human being or other creatures, showing a certain amount of intelligent behaviors. So we may see the game AI is a little bit different with the traditional AI. In this paper, we designed the two NPC behaviors, showing as the picture. One is a task-oriented NPC, and second is disaster-oriented NPC. In the first, they can simulate the behavior of our miners, who guide young miners or students to understand the whole underground mine production, experience an underground mining activity, and improve the relationship between the user and the computer. The first NPC is task-oriented character. When user meets him at somewhere on the ground, he will explain the general knowledge about coal mine and can guide the user to descend a well from the cage. So this is the workflow for the first task-oriented NPC. And the second NPC is a disaster or NPC, who guides the user to experience the typical coal mine disaster, such as gas explosion, rock falling, and a fire accident. In this research, the VR system uses cloud reading and AI behavior tree can enhance the effect of VR training. So it can simulate a realistic and complex underground coal mine environment and provide a function of log-in, roaming, mining, virtual simulation, and operation evaluation. Moreover, due to the limitation of intellectual property rights, only a small part of function can open for the general public on the website. We can see from the feature a cloud rendering cluster is composed by two virtual rendering servers. The server, this whole system has been applied into China University of Mining and Technology in Beijing. The laboratory also has 120-degree two-channel VR project. We can see from the left picture, the laboratory has and also has a infrared laser tracking system. So our system can run on this immersive VR hardware or PC headset. In this system, mining safety accidents focus on gas explosion, rock falling, and fire. Such as gas and coal dust exploration, the user will understand the boundary condition of gas and coal dust exploration. The process of coal and gas outburst animation is established so that the user could perceive the disaster from the vision, auditory, and other aspects, and understand the movement and the destructive process of mixing wind and dust. Also, some emergency preparedness, such as collaborative gas extraction, can be fully displayed. And also we have roof falling and fire accident and other disaster simulations. During the last year, almost 1,700 users visit this training program and rate 5.0, which means the system is in a very high level. However, in order to get a better experience and quick response, the current cloud-rendered hardware need to upgrade to a large cloud-rendering cluster in the future. And performance test is need to estimate amount of concurrency and runtime efficiency. And further research is need to enhance the system function, such as we can combine it with numerical computation. The system can run to be a testbed for mine support design, ventilation design, emergency draining, and other research fields. We expect more application innovation on VR mine training and disaster draining. So I would like to conclude by emphasizing the fact that with the development of intelligent mine construction, virtual reality in mine industry is facing great opportunity and a challenge. Cloud rendering technology will become one of the most important mainstream 3D technology in the future. The gamification of AI also attracts users to take action and strengthen their cognition and learning ability. So in this paper, we designed a cloud virtual reality system for mine safety training with UE. This result is provide a new tool for coal mine work safety and avoid high risk and extreme environment of underground. Thank you. Sorry, due to the limitation of the time, I cannot show some video. If any of you are interested about this research, please contact me immediately. Thank you.
High-discrimination multi-sensor information decision algorithm based on distance vector. College of Physics and Electronic Information Engineering, Qinghai Internationality University. Multi-sensor information function level. Multi-sensor information function include research on transmission protocol and sensor network node information function, both of which are used to solve the reductions problem of information acquisitions in multi-sensor system, so as to improve the accuracy of information acquisitions and reduce the amount of data sent by nodes. Figure 1 is a functional mode of multi-sense information function, whose function process can be divided into multi-levels. Firstly, the source state called by the sensor is pre-processed. Secondly, the function results are obtained by further processing according the application field. The technologies involved in the function include data association, tagging, and identification, situation estimation, impact assessment, and process assessment, among which are higher-level function technologies all involved information decision making. Multi-sensor information function process. Figure 2 shows the basic function process of multi-sensor information, and the function process of data feature are decision making is given in Figure 2. First, the data collected by the sensor is pre-processed, including signal rectification, flattening, and amplification. The first level of function directly sends to pre-processed data to the function center to obtain the function result. In the second level of function, the pre-processed data are extracted for feature and sent to the full function center to get the function result.
This level of function is usually applied to data association and target recognition, and the third level of function is to end the preliminary decision based on the second level of function, and then send the decision result to the function center to get the output result. This level of information function is often used in the field of information decision marking, which belongs to higher level of information function, and the difficulty is increased to center extended compared with the first two levels of function. Multi-sensor information decision model. Feature 3 is a multi-sensor information decision model. There are N decision centigrade and M sensor nodes. First, the measurable range of each sensor is divided into several intervals, and the center measurements value of each interval is taken as an evolution standard, which is placed into N decision centigrade and comparison point to the center respectively. Second, the distance difference between the actual value of the data collected by the sensor node and its corresponding data cloud evolution center needs to be obtained, which can be named the support matrix. That is the support of each accurate measured value relative to the node standard. Third, the support function is obtained by the summing the distance difference between the accurate measurement value of each sensor and at its N evolution center. Finally, the data processing logarithm is used to get the superiority of each group's decision result, and the maximum value is taken as output result of the decision. Logarithm implementation principle. The principle of multi-attribute information decision marking is shown in Figure 3, which is above the screen, is Figure 3, which A1, A2, A5 are the center value of the value range for each sensor corresponding to DR1. Similarly, and A1, A2, and A5 are the center value of the value range for each center corresponding to the DR2. And the B1, B2, B5 are the actual measurement value of the first group. Next, the signal attribute decision making method is extended horizontally to multi-attribute information decision marking, and the decision vector models of the actual measurement value and the center value of the standard decision range is vertically calculated, and the sum of the distance vector models of each decision result is calculated horizontally. The sum of the value is the closer the calculation result is to the decision result. Multi-sensor logarithm based on distance vector. The specific process of multi-sensor decision algorithm based on the distance vector is described as below. Step 1. If there are n evolution levels at m sensors in the evolution system, the value range of the ith sensor corresponding to each level G is AJ minus plus or minus delta t, which ag is the center value at the level g can be vectored as g. Suppose the step 2. Suppose the maximum value of each center is max ai and the minimum value min ai. The actual measurement value is vectored as b and minus ai bi max ai. Step 3. Let ng can be supported degree of g to measure the value of each center, respective the distance from the measurement value bi to the evolution ag. Then the support maximum can be expressed as follows. Equation 1. The support function is obtained from the above equation 1 as follows. Equation 2. Step 3. Step 4. Normalization processing. See equation 3. Then the result of the domination function is equation 4. Step 5. According to the calculation scheme of definition 1 for the normalization function is equation 5. Step 6. Let phi can be discrimination function, then see phi equation 6. Step 7, which is 1. The optimum solution scheme can be solved by the equation 5. Simulation and analysis. Example 1. Assume the temperature of a center water area is 2 grade and the evolution etc. as shown in table 1. This is tested with a temperature sensor and the temperature of current water is set to temperature evolution standard. The calculation result of the normalized function is table 2 can be obtained from table 1, which ddv represents the distance differences between the measure value and the center value. Then sort the calculation result of ice and take max ice as the optimized solution. Example 2. This is assumed that a comprehensive evolution of the pollution of a central water area is report. The evolution center as shown in table 3, the environmental parameter of water college that collected by the center node, including temperature, pH, turbidity, conductive actor, and the actual measurement result as follows. So see the table 3. Evolution century for the water pollution. Then get the support matrix as this as the follow equation n. According to the equation 1, equation 2, and equation 3, the following result can be obtained. And according to the equation 4, the following result can be obtained: S1, S2, and S3, S4. First, source the calculation of ice j and then take max ice as the obtained solution. Example 3. Suppose that a recognized fragment is composed of A, B, and C, and the evolution century of the corresponding evidence as shown in Table 4. Evidence date under the identification framework in the Table 5. Computation of function results are different methods in Table 6. Relation between the recognized rate of C and the number of evidence. Furthermore, the degree of discrimination between the two methods is calculated separately as shown in Table 7. Then the discrimination of the two methods is above 1.5, but when the number of evidence is 4, the discrimination of the method is the paper research 1.7796. However, the DS evidence theory loses comprehensibility due to the inconsistency between the decision result and facts. Next, closing. This study processed a multi-sensor information decision algorithm with high discrimination based on distance vector. And the principle of the algorithm is analyzed from the perspective of single attribute and multi-attribute. The support matrix diminution function and discrimination function of the algorithm can be used to obtain the optimized solution of the decision result and the evidence base of the algorithm performance. The analyzed results show that the discrimination degree of the pro-process method can be reached more than 1.5. It can effectively avoid the conflict problem in the decision-making process compared with the traditional DS evidence theory, and has obviously abundance over the application screenings that need to assess the initial problem of the sensor in the decision-making process. 6. College of Physics and Electronic Information Engineering and College of Physics and Electronic Information Engineering. That's all. Thank you.
My paper is research on monitoring and regularity of coal mine resin extraction state. My name is Wu Chao, come from Shandong University of Science and Technology. My paper consists of 6 blocks. Let's look at the first part, introduction. Coal mine gas extraction technology, which is the main technique measure to prevent gas disaster extent, has also been continuously improved and developed with the coal industry technology, but the overall level is still low. The informatization, intelligence, and standardized and refinements of gas prevention and control technology equipment have just started. The collection, transmission, and intelligence is identification mode of information closed related to the hidden dangers of gas accident are not complete. The key of coal mine gas extraction parameter monitoring, engineering construction, management, effect measurement, and inspection have not yet been digitized and informatized. A lot of data is still in the stage of full manual determination. This is a diagram of gas drainage pipe system. Now we can see the photo of gas drainage pipeline in combine. This is another photo in combine. We can see single hole meter device is not equipped in some coal mine drainage project, so the extraction effect cannot be investigated in time. The gas measure hole and control valves is supplied for main pipeline of each roadway, but not from bridge. So the gas in bridge is out of control, and the linkage of bridge will affect the whole extraction system. Sometimes the extraction system has to be shut down in order to issue the gas concentration of area. The drainage drilling is provided with regulated valve and gas measuring hole, and the valve is stored for sub-pipeline, so each pipeline is under control. But the operation of valve is manual with reach. An air link in one borehole is in some time handled by shut off the whole system, such that it is wasteful and inefficient. There is no effective theoretic guidance but experience for gas concentration of drainage pipeline. So the drainage control is poor, and there are a lot of closing holes, which not only cause a lot waste of resource, but also leave security risk for mine. The extraction concentration of different borehole in some area varies greatly in some time. There were no online monitoring of pressure, flow, and concentration for branch, and even there were not a flow meter or detection hole for main pipeline of pump station. When the concentration of most branch pipeline is lower than normal, how to take the advantage of gas is a big problem. Since the complexity of gas law, there are the following problems in drainage. Accurate mathematical model cannot be established. Conventional control method is unfit to use. Gas parameter measurement is needed for pipeline control. Traditional gas monitoring with wind communication is complex, and the occurrence characteristic and the law of residue gas need to be further studied. So it is necessary to design a gas extraction system to achieve accurate control of pipeline. Work of system for improving gas drainage is to control the pipeline by data acquisition and efficient algorithm, and to estimate the residue gas parameter. Combined with the control technology and wireless sensor network, and the model estimation for gas drainage, the monitor system of gas drainage branch is designed. Data parameters include gas concentration are collected by sensors. The valve operation of bumping bridge can be automatically regulated. The extraction parameters are estimated. Part 2 is the design of monitor system for coal seam gas drainage bridge pipe. The gas drainage and gas concentration in Xuyong coal mine are studied as an object. In order to achieve informatization of gas drainage, concentration and pressure, flow, temperature, and other parameters of pipe network should be collected in time to monitor the system. The system consists of a central node and several sensor acquisition nodes. Each node includes sensor of gas flow, concentration, negative pressure, and other detection devices. Each gas drainage branch pipe is installed with a sensor acquisition node. Only one central node is needed for gas drainage phase not more than 500 meters in length. The monitor feature is achieved by wireless sensor technology. Each branch pipeline is equipped with a controller which periodically collects data of gas concentration, flow rate, and pressure and operating valve, for the negative pressure of a pipe to gas concentration. The function of sensor acquisition node is to collect drainage parameters and transmit the data to the central node by wireless way. It is mainly composed of a microcontroller, concentration sensor, flow sensor, pressure sensor, temperature sensor, microelectric wave, wireless communication circuit. A fuzzy control strategy is adopted for concentration control. The way of wireless and data transmission is fit for the complex and turbulent environment of a coal mine. It can avoid the inflation of wide equipment and pipeline movement, and facilitate the installation for node when mine's position is changed. The sensor acquisition node is installed at the drainage pipeline, and the gas concentration, flow rate, pressure, and temperature are collected and converted by node. The gas concentration in the pipeline is controlled by the fuzzy control. The fuzzy control algorithm is designed according to staff experience. The acquisition node receives the command from the central node and sends the pipeline information back to the central node through wireless communication. The central node is mainly composed of a microcontroller, wireless communication circuit, power, and display. The central node transmits the data to the remote monitoring substation by bus. The central node relays the command to the acquisition node through wireless, and the acquisition node answers to the central node in order. The central node will analyze the information received, fit the change data of gas flow, predict the content and distribution of residue gas, and calculate the drainage circle for engineering reference. Part 3 is the design of fuzzy controller for gas concentration. The sensor acquisition node obtains the gas concentration of the branch pipe and calculates the regional control signal through the fuzzy rule. The signal is intended to control the drainage branch wave so as to adjust the flow and to ensure the minimum gas concentration of the bridge. The deviation of gas concentration and the change rate of gas concentration deviation are selected as the input for a fuzzy controller, so-called two-dimension fuzzy controller. The regulated wave of microelectric wave is the output. The schedule code for concentration fuzzy controller algorithm is called multi-level control as follows. Part 4 is the estimation of gas pre-drainage time. At present, the conventional method to predict the regional pre-drainage time is mainly to determine the initial gas drainage amount and the attenuation coefficient of gas drainage volume. The precondition of that method is that the bump quantity is expectation attenuation. The process of gas drainage can be approximately equivalent to that of water tank drainage. The coal seam is equivalent to water tank, and gas to water in a tank, or branch pipe to a bump, the residue gas content to the water volume. The drainage flow of water bump to the flow of gas drainage. The relationship between the water bump drainage flow and time is very close to that of gas drainage flow and time. If the flow curve is close to curve 1, it can be expressed by the power function formula. If curve 2, then the step response formula of the second-order model. If the dotted line as shown in the figure is added to the curve 1, a step response curve of a second-order model can still be obtained by translating the coordinate axis. Therefore, the model of gas drainage can be expressed by a second-order model. Part 5 is calculation of a residual gas content. Estimation of gas pre-drainage time by second-order model with what condition? That's the part 5. Calculation of residual gas content. In order to obtain the residual gas content after a period of drainage, the original coal C gas content is required first, and the drainage amount of roadway is also considered. We can use this formula to calculate the four factor: Q for original gas content of coal, QT for total amount of gas drainage per ton of coal, QV for residual gas content of coal. Residual gas content after gas drainage is calculated according to the following formula. Part 6 is conclusion. A kind of monitoring system based on wireless communication for gas drainage pipeline is designed. With the sensor, microcontrollers, microelectric wave, and a wireless communicate module, the gas concentration in the branch pipe is under control. The system is beneficial to ensure the concentration level of gas drainage. The further control is applied to the monitoring system of gas drainage branch pipe, and the section multi-level method is present, which improves the automation level of the gas drainage. In this paper, the coal seam drainage model is regarded as a second-order model. By analyzing the characteristic of a gas drainage data curve, it is concluded that the second-order model step response curve is a good choice to fit the date, and a new method for predict the drainage time is proposed. That's all. Thank you.
Hello, ladies and gentlemen. My name is Liu Mingqian. I'm from Xidian University. Today, I'm very happy to join the third EAI International Conference on 6G for Future Wireless Networks. So, I will use a presentation to illustrate this paper. The topic of my presentation is about modulation recognition with alpha stable noise overfitting channels. My presentation concludes 6 parts. The first part is abstract. The second part is introduction. The third part is system model. The fourth part is modulation identification under alpha stable noise and fitting channels. The fifth part is simulation result and analysis. The last part is conclusion. So this paper the abstract of this paper proposed a method based on kernel density estimation and expectation condition maximization. ECM, it means ECM, to realize digital modulation recognition over fitting channels with non-Gaussian noise in the cognitive radio networks. A compound hypothesis test model is adopted here. The KDE method is used to estimate the probability density function of non-Gaussian noise, and the improved ECM algorithm is used to estimate the feeding channel parameters. Numerous results show that the proposed method is robust to the noise type over feeding channels. When the G is known as 10 dB, the correct recognition rate for the digital modulation recognition under non-Gaussian noise is more than 60%. So let's move on to the introduction. I will give a brief introduction about this field. With the rapid development of the communication technology and the increasing attention in the spectrum resource, cognitive radio technology has become one of the key technologies to solve this problem. In the CRN, it means cognitive radio network. Spectrum sensing technology and spectrum effects technology are particularly important. Among them, spectrum sensing technology not only needs to accurately detect the occurrence of authorized user signals, but also needs to identify the modulation type of authorized user signals. Then we can determine the authorized user information such as the type of service, the strength of the service, and so on. CRN technology is easily affected by feeding channels, inter-user interference, and the electromagnetic pulse noise. This interference and noise often highlights that the probability density function is a sigtail of non-Gaussian distribution. Therefore, it has practical engineering significance to study the detailed modulation signal identification and the non-Gaussian feeding channel in CRN. So, several algorithms have been reported to solve modulation recognition based on non-Gaussian noise. Some scholars have studied the data modulation recognition under the alpha-stable distributed noise model. The other authors have studied the modulation recognition under the mixed Gaussian noise distribution. So I give a table. The left part is the method, the right part is problems. You can see the first is the CCES and deep residual neutral network. The CCES is introduced to effectively suppress non-Gaussian noise through the designed Gaussian kernel. The second block is the CS based on FU classification technique. Sorry. The problem of the classifiers degrade due to the presence of the imposed noise. The third block is low-order packet decomposition and neutral network recognition method. It has some problem because it has poor recognition performance and low GSNR. And the fourth block is a Gaussian mixture model is used to model the noise. The identification problem of the amplitude-based modulation signal is studied. The problem is the signal is affected by the feeding of channel, besides a lot of non-Gaussian noise. The fifth block is a signal identification method based on normalized, fractional, low-order for alpha-stable distributed noise feeding channel. So this method has problem is when the GSNR is low, the classification and recognition performance is poor. The last block is a low complexity blind data-driven modulation classifier under uncertain noise condition models using a mixture type of noise. The performance of proposed classifier approach is that of maximum likelihood classifiers with perfect channel knowledge. So I give a brief conclusion of this introduction. You can see in the view of these approved problems, this paper proposed a better and a novel method of modulated signal recognition under the alpha-stable distributed noise feeding channel. It has some features. The first is the kernel density estimation algorithm is used to estimate the probability density function of the alpha-stable distributed noise. The second feature is the improved expectation conditions maximization algorithm is then used to estimate the feeding channel parameters. And the third is the modulation type of signal is identified according to the composed hypothesis test model. And the simulation result tell us when the characteristics index of alpha-stable distributed noise is 1.5 and GSNR is 10 dB, the recognition rate of the signal in the feeding channel is more than 60%. So let's move on the system model. The B is identified the number of classes of all possible modulation types, and the transmitted signal of class B can be expressed as this equation. And in CRN, the model of received signal can be described as this equation, and the sample received signal can be expressed as the third equation. Use the different equations express the different signals, the transmitted signal, the received signal, and sampling signal. And this equation means because the alpha stable distribution doesn't have a uniform closed PDF. So we can use this equation to describe it from one aspect. And I will give two parts. The A part is probability density function estimation of alpha stable distributed noise. Sorry, excuse. We assume that each symbol in the sample set is independent, and always the distribution of PDF. So we assume that in a small area, and we estimate the probability density. If a small area is in the space where the sample is located, the probability that a random variable is in the area is this equation. And known by the identification of binomial distribution, the probability of that independent identified distributed sample of sample set are in the area is, first we estimate the probability density in this area. It seems this equation, the condition is similar, and the equation is similar. So we have completed the probability density estimation in a small area. Oh, I'm sorry. Just now my computer, something wrong with my computer. So the video software is blocked, and now I continue to do my presentation. Just now we give the probability density estimation in the small area, the equation to describe this, and the probability density function estimate in this phase is not continuous. Therefore, this paper uses the KDE method. We assume that a d-dimensional vector, each small volume is hypercube. Each dimension has an each length of and each small volume. So the d-dimensional unit window function is used to calculate the number of samples falling into each small volume. And this equation shows whether the number in the cube whose center is and whose edge length is. So, and the PDF estimate at point is, you can use this equation, you can see it. We can define the kernel function as here. In short, a kernel density estimation process needs to move the kernel function to the position of each observation and each select the global bandwidth to control the smoothness of the probability density function of the expansion of the kernel function. The reverse evaluation formula is. And the part B is estimation of feeding channels parameters. Based on the principle of ECM algorithm, the parameter estimation steps of the proposed feeding channel are as follows. The first is E step. We can use this equation to express the E step. And by combine the first equation and the by Bayesian theory, the second equation, we finally can obtain this equation. This is E step. So the second part is an M step. The M step is maximize in the E step to find a new estimate of some unknown parameter. So we will use this equation. The E step of the ECM algorithm is same as the EM algorithm. And part C is modulation recognition based on compound hypothesis test. We use the KDE method to estimate the PDF of alpha stable noise distribution. We can use the just last equation, and we can get this equation. This equation is the process of modulation of recognition under non-Gaussian feeding channels. So I will give some simulation results to support my system model and to support this method. You can see, in order to verify the effectiveness of this method, simulation results are carried out by MATLAB simulation software. The simulation, the red part is the simulation result. You can see the red line is BPSK, the blue line is QPSK, the black line is 16 QAM, and green line is 64 QAM. The fourth line decreased represents the digital modulated signal, and the noise is a adaptive standard distributed noise. The carrier frequency of the modulated signal is 10,000 Hz. The code element rate is 1,200 baud. The rule-of factor of this shipping filter is 0.34. The sampling frequency is 40 kHz. The number of signal sampling points is 3,000. The number of Monte Carlo simulation is 2,000. Sorry. My throat is bad, sorry. And the simulation result and analysis. You can see the recognition performance of the signal at different GSNR. It can be seen that recognition performance of different signals and the feeding channel increased as the GSNR increase. When the GSNR is 10 dB, the recognition accuracy of different signals is more than 90%. It can be seen that the proposed identification method has better the recognition performance and the feeding channel. It is effective and feasible. So the conclusion is aiming at the problem of modulation recognition in the non-Gaussian feeding channel in cognitive networks. This paper proposed the modulation recognition model based on composite hypothesis test suitable for this. And this model, the probability density function of non-Gaussian noise is estimated by the kernel density estimation method. The parameters of the feeding channel are estimated using an improved expectation condition maximization algorithm. The simulation results show that the proposed identification method is effective and feasible, and the non-Gaussian noise feeding channels are robust to different noise types. So, thanks everyone. My PowerPoint is done. Thanks for everyone listening. Okay, thank you.
Hello everyone, my name is Nanjun He from Henan Polytechnic University, China. I'm honored to participate in this conference, and then I will describe my thesis. The topic of my thesis is improved linear threshold model. It is divided 5 parts in total. The first part is the analysis of the correct situation. The second part is the deficiencies in this declaration. The third part is the situation and innovations. The fifth part is the experimental evolution, and the fifth part is the conclusion. What is influence maximization? Maximization of influence have the following definition. The process of the finding a set of most influential key points in social networks and make these key points the largest spread range. Social network platforms such as Facebook, WeChat, Twitter have become widely used methods that people can communicate with each other. As one of the most important problems in the social network analysis, The problem of influence maximization have attracted tremendous attention. It aims to find a small set of influential nodes so that the influence those nodes can be spread most widely. Although the problem is first raised in the field of marketing, it is excited in many other fields such as political movements, rumor controlling, and so on. Propagation model. Kemp first proposed two classical basic models, one LT model, two IC model. Many researchers have made improvements based on LT model, who processed a competitive LT model to block the influence of competing products. Blogger extend the LT model to give each node a decision-making ability about the incoming influence spread. Greenhalgh, Zhang, and Yang concerned on the improvement of LT model to allow a node to be each positive or negative in the speed process of information or influence. Zhang and Korea revised LT model to separate influence according to the trust or distrust relationships. Chan proposed the non-progressive LT model to detail the case in which active nodes may become inactive. The carried shortcomings of this declaration. The classical propagation model is proposed, but the time cost and the propagation effects problem caused by iterative calculation in the influence maximization have yet to be resolved. Although much effort have been made on the improvement of LT model, the convergence problem of the model is still an open problem. The first is the introduction of definitions. We have introduced two definitions: ready active state and potential influence. Definition 1: ready active state. VI is in the ready active state if VI satisfies the following condition. 1. The influence from all the active neighborhood of VI reach up to overpass the predefined threshold, and no activation operation have been performed on VI. Definition 2: potential influence. The potential influence of VI indicates the influence from its ready active neighbors. It is calculated by fraction. We take a picture as the example to illustrate the influence spirit with the improvement of LT model. In the ETL state, the second node and the first node are regarded as seed nodes. The state of two nodes are active, and the remaining nodes are inactive. The first iteration, the second node have influence on first node, exceed threshold, and the first node transition to the active state. Similarly, the fourth node also become active. The sum of influence of the second node on the third node and the potential influence of third node on fourth node on third node is exceed threshold, and third node is changed into the ready active state. The activation operation is performed on the third node, and the third node is changed into active state. The remaining node keeping being inactive. In the second iteration, the influence of the sixth node comes from the third node is overpass the threshold, and the sixth node is changed into active state. The sum of influence the node, the fifth node on the seventh node, and the potential influence of sixth node on seventh node is exceed threshold. So the seventh node changed into the ready active state. The activation operation is performed on the seventh node. The seventh node is changed into the active state. The remaining nodes keeping being inactive. The third iteration, the seventh node has influence on the eighth node. This is exceed threshold. So the eighth node changed into active state. Similarly, the ninth node is also activated. The other node states remain unchanged. The fourth iteration, no nodes can be activated, so the iteration converges. This page is the introduction of procedure code. We can summarize the following steps to understand this improved model. Step 1, the set cases nodes, seed nodes are marked as active, and the remaining nodes are marked inactive. For step 2, the nodes in the active state, the influence and potential influence of the inactive neighbors are calculated separately. Step 3, according to the result of calculate, the state is converted in the order of rulers. Step 4, step 2 and step 3 are repeated. And the algorithm converges when the real of the difference between the number of active nodes and the total number of nodes is less than C. Step 5. Calculate the number of all active nodes as the final propagation result. Evolution indicator, spread time and spread range. All these datasets are collected from Stanford Large Network Dataset Calculation. As shown in the table, it is detailed inductor of the dataset, including the node of dataset, the number of nodes, and the number of edges, the data size, and the type. According to the picture, the picture shows the EQ time of our model and LT model on different datasets. According to the figure, our model converges faster than LT model on all datasets, no matter which algorithm is used to select seeds. According to the picture, our model activates the same number of nodes of LT model. That is, our model exhibits the similar ability to spread influence to LT model. That means our model improves the performance of influence spread while guaranteeing the efficiency when compared with LT model. Conclusion: LT model is one of the diffusion models widely used in solutions of influence maximization. In this work, we focus on the convergence problem of LT model. We analyze the reasons limiting the convergence speed of model and propose an improvement of that model. The improved model makes the activation decisions according to the not only active nodes, but also the inactive nodes to be activated soon. The experiment results on abandoned datasets verify the performance and the efficiency of the improved model. In the future, we will research the application of linear threshold model in competitive environments.
Hello everyone, I'm Tianming Feng from Harbin Institute of Technology. And the title of my paper is Performance Analysis for Caching in Multi-Tier IoT Networks with Joint Transmission. I will introduce my paper from the following 6 aspects. And first, I'll present the introduction. The rapidly growing number of mobile IoT devices on the network has led to explosive growing in the demand for mobile data traffic. Deploying multi-tier edge base stations to form a heterogeneous network has become an effective solution to meet these demands. However, densely deployed base stations will inevitably cause high inter-cell interference. Joint transmission, where a user is simultaneously served by several base stations, can effectively mitigate the interference. A large portion of the traffic is caused by repeatedly downloading a few popular contents, caching the popular contents at the edge of the IoT network, such as edge base stations. IoT devices can greatly reduce the traffic burden of IoT network. The concept of caching technology has been extensively studied in the recent years, and however, all the aforementioned works that jointly consider joint transmission and caching technology in multi-tier networks only limit the content caching strategy designed to the single-tier base stations. That is, only one tier of base stations in the network have cache capacity. The base stations from other tiers do not have the ability to cache. Moreover, the base station cooperation is just limited to the base stations from the same tier. In this paper, the content caching strategy with BSGT is studied in a cache-enabled multi-tier IoT network. Different from the existing literature, every tier of base stations in our model has cache capacity to store a limited number of contents. Joint transmission scheme is adopted in this work, under which the user is jointly served by the nearest base stations that cache the requested contents from each tier. And I'll introduce the system model next. We consider the downlink large-scale CMIN consisting of M tiers of base stations, and the base stations in the M tier is represented by independent homogeneous Poisson point process with density lambda m and transmission power pm. We focus on the analysis of a typical user equipment U0 located at the origin. The signal power received at U0 when served by a base station located at XM from the mth tier is like this, and where Rm is the path loss exponent and Hxm denotes the relay fading. Consider a database consisting of n different files, and the popularity of file n is denoted as an, satisfying the zip distribution like this. HUE randomly requests one file according to the file popularity distribution in one time slot, and each base station from tier M has a limited cache size CM. Consider a random caching scheme where the file N is stored in a base station from tier M randomly with probability TMN, which is called the caching probability, and we have the following constraints. And the cooperative base station set is denoted by CN, and it can be represented like this. We adopt a non-coherent joint transmission scheme, where the typical user equipment U0 is served jointly by the nearest base stations that cache the requested file from each tier. XKN0 represents the nearest base station to U0 from tier key that stores file in. And this is the figure that illustrates two-tier CMIN with joint transmission. And the received signal at U0 when requesting file in can be written as like this. And the first item is the desired signal, and the second item is the interference and the user received. And they represent the background thermal noise. And based on this received signal, and the SIR when a user requesting file in can be expressed as this equation. And we employ the successful transmission probability (STP) as the system performance metric like this. The probability that SIR is larger than tau. And QN denotes the STP when U0 requests the file in. And for notational simplicity, we define the PIJ equals to PJ over PI over PJ, and lambda IJ equals to lambda I over lambda J. And next, we introduce the analysis of performance metric. First, we define a function f(x), where this item is the Gauss hypergeometric function. And we have the following theorem. The STP for the joint transmission scheme considered in this work is given by this equation, and the conditional STP is expressed as equation 10, where R0 is the distance vector between the typical user equipment and its serving BS, and R is a realization of R0. FRK0 is the probability density function of RK0, which can be given as this, and the QNR0 is the STP conditioned on R0 equals to R. And this figure plots the STP versus tau with and without joint transmission respectively. We can see that the derived analytical expression of STP and matches the Monte Carlo simulation results perfectly. Besides, the STP of the system with BSGT has greatly improved compared to the non-cooperation scheme like this, which confirms the effectiveness of the BSGT. Next, we give a corollary. For the two-tier network where m equals to 2, let alpha 1 equals to alpha 2 equals to alpha. The STP is given by this, and this corollary is simply derived from the theorem we gave before. We can observe that the STP is not only influenced by the caching probability, the path loss exponent, and the SIR threshold, but also affected by the ratios of transmission power and the base station density respectively, when m equals to 2. And we'll introduce the STP maximization. In this section, we maximize the STP by optimizing the placement probability metric T for the two-tier LT networks. The optimization problem for this case can be formulated as this, and the constraints are the two we introduced in for the caching probability TMN. And we can observe that the constraint set is convex, whereas the convexity of the objection function is hard to determine because of its complicated expression. Therefore, a locally optimal caching strategy can be obtained using the gradient projection method. This algorithm gives the procedure of the gradient projection method, and the first step is initialization, and the loop, and this is the project of TMN on the convex constraint set. And in the step 3 of algorithm 1, the step size Sk satisfies these two equations. The step size Stk, and the partial derivative is given by these equations. This is the partial derivative. And then next, we'll introduce the numerical results. In this part, some simulations are conducted to compare the LCS obtained by algorithm 1 with 3 baseline strategies: MPC, most popular caching, independent identical distribution caching, and uniform distribution caching. Without other explanation, we set the parameters as the following. From this figure, we can observe that the LCS outperforms all the 3 baselines. When tau is small, the LCS is consistent with the IIDC. And when tau is large, the LCS is consistent with the MPC. This is the MPC. This is the IIDC, and this is the UDC. LCS. This figure depicts the locally optimal caching vector T1. This figure shows the locally optimal caching vector T1 star. From the figure, we can see that files of higher popularity have higher probability to be cached at base stations. And we can see that when tau is large, the LCS is consistent with the MPC, where the probabilities of some files is 1 and the remaining files is 0, like this. And we have the conclusion. We developed a joint transmission scheme and derived the SDP expression for the key tier cache-enabled IoT networks, and when adopting random caching scheme. The locally optimal caching strategy was obtained by using the gradient projection method, and simulations were conducted to verify the established STP model and compare the SCS with 3 baseline strategies, and MDP, IIDC, and UDC. This is the references. And that's all. Thank you.
Hello everyone, my name is Zheng Shuai. I come from Henan Polytechnic University. It is my honor to be here to give you this report about the paper Collaborative Mobile Edge Caching Strategy Based on Deep Reinforcement Learning. As shown in the PowerPoint, my report today is divided into 4 parts. Part 1, Research Background. Part 2, System Architecture. Part 3, Our idea and the experiment. Part 4, the conclusion and future work. Okay, let's move into the first part. The first part is about our research background. Recently, with the advent of the 5th generation mobile networks era, the emergence of mobile edge devices has accelerated. The generation of massive edge data brought by massive edge devices challenges the connectivity and the cake computing capabilities of the Internet of Things devices. The complexity and heterogeneity of the devices in the edge cake scenario make it unable to meet the low latency requirements of 5G. Therefore, it is necessary to deploy small or portable data centers at the edge of the network and use artificial intelligence technology to intelligently process terminal requests locally to meet the Euro low latency requirements of URLLC and MMTC. However, considering the high cost of deploying data centers at the edge of the network, mobile edge caching is a promising solution. In this research background, we aim to bring more intelligence to mobile edge caching, solve high-dimensional time-varying edge scene, solve resource imbalance problem. Based on the above problems currently existing in the edge cake, our ideas are the following. In order to realize cooperative caching in edge scenarios, the macro-base stations cooperation space and macro-base stations cooperation space is convinced in this paper. Deep reinforcement learning algorithms with perception and decision-making capabilities are also used to implement collaborative edge caching. DRL agents perform original and high-dimensional observation trained on high-dimensional edge cake scenes, which can effectively solve the dimensionality problem. Besides, we jointly deployed federated learning locally to train DRL agents, which not only solved the problem of resource imbalance, but also realized the localization of train data. Next to the second part. The second part is about system architecture. As shown in the above architecture diagram,
We assume that both the KCBS and the MUBS are equipped with MEC servers to realize collaborative caching of user devices in the collaboration space. Further analyze the architecture diagram. We define a two-level collaboration space. The first level collaboration space between IoT devices covered by the same MUBS is called the MUBS collaboration space, and the EN in this collaboration space is called a direct EN helper. The secondary cooperative space formed by the MUBS, where UE is located, is counted in LB hope and covered by the same KCBS, which is called the KCBS cooperative space, and EN in this scope is called indirect EN helper. Through the cooperation of nodes between the two levels of collaborative space, the pressure of data center can be relieved and the QoS can be improved. When the UE sends a request, the request is accepted and processed by BS or sent to the remote cloud for processing. This process involves the BS and the cloud, and the transmission between the UE and the cloud. We use a specific UE to send a CAC request as an example to illustrate the model. The UE first sends the CAC request to the direct EN helper. The DRL agent placed in the direct EN helper observes the available computing and CAC resources at the edge of the network, and design a corresponding resource allocation plan based on perception. If the requested content is available in the direct EN helper, the kicked content can be transmitted directly through wireless transmission. When the method can't meet the requirements of the UE, the KCBS covering the UE needs to be used. Searching for requested content at other indirect EN helper, and if the content exists in a KCBS buffer, it may be sent to the user through the backhaul link. If the above steps do not meet the user's needs, the agent will send the content requests to the cloud data center. Let's talk about our ideas and experiments. The third part is about our idea and the experiment. Through the above steps, the optimal strategy is finally obtained. It is effective for DRL technology to find the optimal strategy for a dynamic edge system. But it also needs a lot of computing resources. Therefore, we should consider the issue of DRL agent deployment. The learning process of DRL based on FL. First type. At each moment, agents interact with the environment to obtain a high-dimensional observation and use DL method to perceive the observation so as to obtain an abstract and concrete representation of state features. Second step. Evaluate the value function of each action based on the expected report and map the current state into the corresponding action through strategies. Third step. React to the environment and actions and get the next observation. The main algorithm is shown here. Here merely introduces the execution process of the algorithm and the setting of some parameters. Finally, we introduced the experimental conclusions and future work. The first part is about the conclusion and future work. First, let's take a look at the experimental conclusions. Figure 3a with the increase of the probability of the renal of the cake task. The energy consumption of the FL-based DDQN cooperative cake scheme processed in this paper is lower than that of the traditional controlled twin DRL proxy method, which indicates that the collaborative cake strategy proposed in this paper has better energy-saving performance. Then, we evaluated the change of DDQN twin loss with twin duration. It can be seen from figure 3b that as the twin time increases, the twin loss gradually decreases. Finally, we assume that the task request probability is the same. Select 3 UES and evaluate the cake hit rate according to the changes in the number of twins, as shown in figure 3c. We can see that the hit rate is gradually increasing. Which shows the effectiveness of the proposed scheme and can graduate QoS. Next, let's introduce our future work. Our next work mainly has two directions. 1. Device-to-device cooperative catching. 2. improve the architecture and experiment. At this point, our content is all introduced. Thanks for your watching.
Hello everyone, today my topic is MPR selection based on link transmission quality and motion similarity in OLSR for FANETs. This is the outline of my talk. I divided my presentation into 4 parts: introduction, algorithm description, result and discussion, and conclusion. With the development of 5G networks and UAV application, flying ad hoc networks has received more and more attention. First of all, I will give a brief introduction to the ad hoc networks. Mobile ad hoc networks are widely used in the military communication and civil applications, such as wireless multimedia servers and disaster management. For the future of mobility and node infrastructure, nodes in the networks may work as routers, and the energy of nodes is often provided by battery, so the network's lifetime is limited. When the network topology changes frequently, it's very important to establish a stable routing, because that can effectively reduce the number of rerouting, thus the overall network's length and routing overhead decrease. However, the traditional routing protocol lacks an effective mechanism to ensure the stability of the route. FANETs is an extended application of VANETs in the field of drones. The faster and accurate data transmission mechanism is an important part of FANETs. However, due to the feature of high mobility, low density, and limited energy, the routing protocols used in traditional MANETs and VANETs are usually not able to adapt the highly change of topology and routing information in FANETs. Therefore, design a suitable routing protocol for FANETs is especially critical. The optimized link state routing protocol is a proactive routing protocol with a float topology. Compared with OLSR protocol, it mainly has the following two characters: the multi-point relay and the advertised neighbor sequence number. The MPR method of traditional OLSR is based on the connection degree. However, due to the high mobility and stability of the link between the nodes decreased, and the larger coverage of FANETs also make the link quality different. As a result, it's inappropriate to adopt the single node degree as the station criterion of the MPR set. In FANETs, the relative movement between each node can usually represent the link survival time and stability. The link transmission quality between nodes can be characterized by expectative transmission count, ETX. Therefore, this paper will introduce the node motion similarity and the transmission quality as the criterion for selecting MPR site. This paper assumed that each node can know its position and speed information in order to calculate the motion similarity. Generally speaking, the greater the degree of similarity behaviors between nodes, those nodes are considered to be better able to maintain the connection state. Now suppose that there are two nodes. Then the calculation of the motion similarity of these two nodes are as shown. The link transmission quality is calculated by ETX. ETX is obtained by calculating the values of link quality and neighbor link quality according to the ratio of two nodes receiving hello message sent by its neighbors within a certain precision. Then the calculation method of ETX of a node is as follows. However, it was found that link quality and neighbor link quality can't be directly calculated. Therefore, this paper defines the measure link quality as an intermediate quantity. Then the ETX calculation method is as follows. But it's found that the range of motion similarity is 0 to 1, while the value range of ETX is 1 to positive infinity. This leads the inconvenience of normalizing of the two index. Therefore, this paper defines a new link transmission quality index (RETX) with value range 0 to 1. Therefore, the two indicators of link stability and transmission quality between nodes are comprehensively considered, and since MPR is used to cover two hop neighbors, the transitivity and relay application must be considered. In this picture, the comprehensive link evolution index L is used to replace the node connection degree in the standard MPR selection algorithm as the decision basis to optimize the MPR set selection method. Among them, A is the node that performs the MPR set calculation. Y is the one-hop neighbor node of node A, and S is the structurally symmetric two-hop node, reachable by Y in the node two-hop neighbor set. Alpha and beta are weighting functions, which can be adjusted for different network directions. In order to obtain the values described in the formula and add them to the protocol, it's necessary to modify the format of hello packet, local link set, and neighbor set, and add some new parameters. Based on the optimized packet format of the hello message and the table format of the neighbor information base, the improvement of MPR set selection algorithm is implemented. The process of optimizing the MPR set selection algorithm is as follows. First, as all nodes in node A's one-hop neighbor set whose folding intention is will always, that is, the value of unwillingness is 7 to MPR set. Secondly, if there is a node in two-hop neighbor set that is not covered by at least one node in the MPR set, then calculate the integrated link index of each node in the one-hop neighbor set. Thirdly, compare the link index of each node and add the node with the largest value to MPR set. If the value of L is the same, the node with the largest intention willingness is set to join the MPR set. Then remove the nodes in the two-hop neighbor set that are covered by the MPR set. In this paper, we use NS2 to analyze the performance of routing protocol in order to accurately simulate the movement set of FANETs. The mobile model uses paparazzi model. For wireless propagation model, the two-phase propagation model can be used to simulate the article folding of FANETs communication, corresponding to the two-ray ground model in NS2, and other parameters of the simulation are shown in the following table. This paper focuses on three performance parameters: average end-to-end delay, packet delivery ratio, and routing overhead. Since the main research of this paper is OLSR protocol, the size of packets is uncertain. In addition, the packet format of hello message is modified, which further leads to the change of routing control packet size. Therefore, in order to accurately measure the cost, this paper uses the ratio of the number of packets received by the destination node to the number of bits contained in the routing control packet as the rating overhead measurement standard. That is the number of routing control packets required for successful transmission of 1-bit data packet. With the increase of the maximum speed, the change of the network's topology is further accelerated. The overall PDR shows a downward trend. However, the OLSR that uses node link stability and transmission quality instead of the node degree as the new MPR set selection criterion can be better adapted to the rapid topology change. Its performance is better and more stable. The main reason is that the movement of the nodes is considered when selecting the MPR node, so that the relative mobility of the link is smaller and the swivel time is longer. This figure shows the average end-to-end delay of the two routing criticals. It can be seen that the average end-to-end delay of the optimized OLSR is less than the original critical. When the node speed is low, the algorithm proposed in this paper refers to the link transmission quality when selecting MPR. Although the average delay of the performance is not much different, it still has an improvement. When the node speed is high, the delay performance improvement is more obvious. The reason is that the selection of MPR set in this paper is more stable, and the communication link quality is better, so as to reduce the delay. As shown in this figure, the performance comprehension of the two routing criticals in terms of routing overhead. The MPR selection optimization algorithm based on motion similarity and link transmission quality can effectively reduce the frequency of MPR selector set, member changes, and TC message transmission, so that the routing overhead is reduced to a certain extent. However, due to the modification of the hello packet, the packet size has more than doubled the original critical, and the MPR uses a fixed transmission interval. This makes the overall routing overhead of the optimization algorithm increase. This problem is obviously not what we want. In the future, we will listen to the topology changes and optimize the routing protocol by adjusting the interval adaptively. Next is the conclusion. This paper firstly introduced the problems in FANETs. Then this paper redesigned the MPR set selection criterion and replaced the node degree with the weighted comprehensive link index to calculate the MPR set. Finally, the simulation compares the three performance of the average end-to-end delay (PDR) and the routing overhead of the OLSR and the optimized MPR selection algorithm proposed in this paper. As shown in the figures, the optimized MPR set selection algorithm based on node link transmission quality and motion similarity have improved PDR and end-to-end delay performance, but at borrows greater routing overhead. We will consider adjusting the transmission interval of routing control packets adaptively to reduce overhead in the future. That's all. Thank you.
Hello everyone, this is is research of D2D receivers fair allocation logarithm in graph query. I will explain my thesis in the following 4 parts. Part 1. Research background. At present, the continuous development of mobile communication technology and Internet technology has promoted the popularization of various intelligent terminals and the increase in the number of users, which ultimately led to a serious shortage of special resources. Device-to-device technology is a communication method under the control of a singular system which can communicate directly by shared records of singular users at the same time. D2D users will share the spectral resources of singular users so that the utilization of spectral resources is improved. And the problem of shortage of spectral resources for wireless communications is solved. Therefore, D2D communication technology is listed as one of key technologies in the new generation mobile communication system. However, when D2D communication is introduced into a singular network, it will cause serious interference. It is of great spectacle significance and research value how to locate the resources reliable so as to improve the spectral utilization rate of the system and enhance the fairness of users receive service. Part 2. Research context. This is the system model. This article considers a scenario where the unlike spectral results are multiplexed by D2D users in the network. Scenario where Sicilian users and D2D users share results. And so is figure assume that the base states is locked in the center of the cell. This have M Sicilian users and N D2D users are readily distributed in the cell, and the number of D2D users in the system is greater than the number of singular users. Its D2D users X is a pair consists of the transmit and receive terminal, and it is assumed that the internal transmission power of data transmission of D2D users is the same. In order to improve the spectral utilization, multiplex D2D users are allocated to share the channel users of the same Sicilian user. The optimization goal of this paper is to find an optimal matrix for receiver allocation and to ensure the user quality of service of the system's thought level as much as possible to improve the fairness of user reserve equation. This formula is when the spectrum reservoirs of similar users are multiplied and shared by multiple D2D users at the same time. The signal-to-noise of similar users is less familiar. The interface received by the D2D user in the system include interface from similar users and interface from D2D users that multiplex to the same reservoirs at the same time, so the signal-to-noise region of the D2D users server. This formula is ordered to ensure the communication quality of users. Some constructs are set. According to the actual situation in the signal cell network system, in which D2D users are similar users coexist. D2D users exist in the system are either communication method which cause a discrepancy in the server's rate of D2D users. In order to avoid this situation and a seater occupied external user reservoirs is excessive, a priority factor is added to the reservoir allocation to adjust the user's calorie order, which is used to improve the fairness of user reservoirs. Allocation in the fair results allocation based on the graph calorie or users in the network system are actually abstract as verticals in the graph, and the interface suffered by the use is abstract as arcs in the graph, so a space of interface can be constructed. Figure G. Construct interface graph. In order to avoid the problem that your pole channel quality cannot be allocated resource for a long time and improve the server's rate of D2D users, this paper process a graph calorie fair reservoirs allocation strategy to improve resource allocate calorie process. In order to avoid the problem that is with poor channel quality cannot allocate the resources for a long time and improve the server's rate of D2D users. This paper proposes a graph calorie fair resource allocation strategy in the place of graph calorie to improve the fairness of users' access to reservoirs. During the graph calorie process, it avoids the problem of not calorie due to excess this application of channel receivers, so the priority factor of user clover can be set during reservoir allocation and improve the reservoir allocation logarithm based on graph color. The implements states as follows. Part 3. Law of simulation results. The figure shows the relationship between the fairness of system D2D resolvers, location other different group, color resolvers, location logarithm. It can be seen from a figure that the greater the number of D2D users accessed in the system, the variance of fairness of resolvers located in the system. Among that, when is the proper number of D2D users accessed in the system with the sweepers, because the number of D2D users accessed in the same network is not large, there is not much interference, so the fairness of resolvers allocation over 4 log is particular different small. This figure shows the relationship between the number of D2D users access the system and the throughput. It is known from the simulation results that the 3 logarithm of IFCA, DVCA, and TGCA are based on isonormal communication between users and multiply pairs of D2D users to resolve the resolver of the same similar users to achieve maximum utilization of channel resolvers. However, when more D2D users are connected to the system, the higher the throughput of the system, the worse of communication service quality of the users. The figure compares the system packet load rate of number of D2D users connected to the system number different logarithm. It can be seen from the figure that the number of D2D users in the system increases. The data packet in the system are more likely to be lost. The logarithm IFCA considers the delay and properties factor of for the fairness of user resolvers schedule, which avoid some users from occupying too much resolver, improve the server rate of D2D users, and reduce the system packet loss rate. Part 4. Conclusion. In the paper showed the communication model of heterogeneous network, the problem of resolver allocation in the environment with D2D users are much larger than similar users is studied, so that the spatial utilization rate have been effectively improved in order to ensure the throughput of the system and the fairness of users' access to resolvers. Resolver fairness allocation logarithm based on graph color result is proceed. Simulation result so that the proposed logarithm can improve the fairness of D2D users to obtain resolvers and reduce the packet loss rate or the promise of ensure the system throughput, which can better guarantee the quality of service of users in the system. However, in this paper, we only consider the interface problem when D2D users and similar users coexist in the signal cell, while ignore the interface between users in multiplex cell. Further research can be done in this regard in the future. Thanks.
Hi, my name is Li Kai. Today I'll be talking about UAV-powered Cooperative Anti-Interference (MEC) network for intelligent agriculture. I'll be speak from 5 aspects, including research background, system model, problem formulation and solution, simulation results, and conclusion. First, research background. With the maturity and commercial deployment of Internet of Things, smart applications have been gradually applied to intelligent agriculture. Due to the explosive growth of IoT devices in intelligent agriculture systems, a variety of real-time environmental information needs to be collected for ensuring yield and quality. Insufficient computing resources have become a problem. Mobile edge computing technology is able to provide cloud computing services for IoT devices and assist IoT devices in completing computation intense and time-critical tasks through wireless access networks. However, inadequate battery supply for IoT devices can impact MEC performance severely. Wireless power transfer is able to provide sustainable and low-cost energy supply for low-power mobile devices from radio frequency signals, greatly extending the standby time of mobile devices. IoT devices are usually located in remote areas in intelligent agriculture. If the IoT device exceeds the range of wireless communication during the communication process, it will cause the communication with MEC to fail. Because of its highly flexible characteristic, UAVs have been widely used in a variety of scenarios. However, WPT-enabled wireless communication networks are vulnerable to the double near-far effect. IoT device located far away from ET requires less energy but needs to communicate for a long distance. Through cooperation between closer devices and farther devices, communication performance can be improved. The cooperation of devices in wireless-powered communication was studied by H. Liang to surmount the double near-far effect, in which the closer device used the same channel to assist the farther devices, causing interference. In order to surmount the interference in the process of IoT devices cooperation, we proposed an UAV-powered cooperative anti-interference mobile edge computing strategy for intelligent agriculture, where the IoT device, which is closer to the UAV, transmits the information of the farther IoT devices and its own information by utilizing distinct subcarriers. The UAV-powered MEC network consists of one UAV and 2 IoT devices. They transmit their task with half-duplexed mode. We adopt a harvest then offload protocol for wireless power computation offloading, which uses a block-based TDMA structure with the duration of each block being t seconds. Since input data is much larger than output data, we only consider the time of the WPT and uplink offloading as the total latency of the proposed UAV-powered MEC system. The signal is OFDM modulated on K subcarriers in order to surmount the interference. IOD2 utilizes first half the subcarriers to relay the tasks of IOD1 and the other half subcarriers to transfer its own offloading tasks to UAV. In the first third of T, UAV transmits signal to IOD1 and IOD2 over subcarrier K with power Pk at the same time, which is equally allocated. The harvest energy of IOD-I is given as follows, where Vi denotes the energy conversion efficiency at IOD-I, gamma Ik denotes the channel power gain on subcarrier K from UAV to IOD-I. In the second third of T, IOD-1 uses harvest energy to send offloading task to IOD-2 with power P1K. The offloading tasks L12 is given by the following equation, where B denotes the channel bandwidth of subcarrier, gamma 3K denotes the channel power gain on subcarrier K from IOD1 to IOD2, and the N2 denotes the receiver noise power at the IOD2. The energy consumed by offloading tasks from IOD1 to IOD2 is given by E of 1. In the last third of T, IOD2 uses harvest energy to forward the IOD1's offloading task to UAV over subcarrier K with power P21K. The offloading task is given by L21, where gamma 4K denotes the channel power gain over subcarrier K from IOD2 to UAV, and the M0 denotes the receiver noise power at the IOD2. Meanwhile, IOD2 sends its own offloading task to UAV over subcarrier K with power P22K. The offloading task L2 is given by the following equation. The energy consumed by offloading tasks from IOD2 to UAV is given by the equation of E of 2. Thus, the offloading task size of IOD1 with the relaying of the IOD2 is the smaller one between L12 and L21. The rest of data needs to be computed locally at IOD-I, which satisfies the constraint that the time spent for local computing is no greater than T, where Ci denotes the amount of computing resources required to calculate 1 bit input data. Fi denotes the CPU frequency. The minimum offloading data of IOD-I is denoted as Mi+. The energy consumption of IOD-I for local computation is given by the equation of E local I, where Ki is the effective capacitance coefficient depending on the chip architecture. After calculating the energy consumption of IOD-I for local computation, we can get IOD-I saving energy where vector P equals to P1K, P21K, and P22K. In order to minimize the transmission energy of UAV, the power allocation is optimized under the time delay constraint and the task size constraint. The optimization problem is given by the following formulas. The object is to minimize P0, subject to C1. IOD1 saving energy is greater than or equal to 0. C2. IOD2 saving energy is greater than or equal to 0. C3. The offloading task L1 is greater than or equal to the minimum offloading data of IOD I and less than or equal to the size of input data of IOD 1. C4. The offloading task L2 is greater than or equal to the minimum offloading data of IOD 2 and less than or equal to the size of input data of IOD 2. P1 can be equivalently converted into P2, which is given by the following formulas, where the value of N1, N2, N1, and N2 come from the equation L21 equals to N1 plus, L21 equals to I1, L2 equals to N2 plus, L2 equals to I2, respectively. Considering L12 ranges from N1 plus to I1, the range of P1K is from N3 to N4. And the solution. Let F be the value of the given equation. From C5, we can see that when F reaches its maximum value, P0 reaches its minimum value. Calculating the first derivation of F with P1K and P21K, we can get the conclusion that F increases monotonically with P1K and decreases monotonically with P21K. Let Y be the value of the given equation. From C6, we can get that P0 reaches its minimum value when Y reaches its maximum value. Calculating the first derivation of Y with P21K and P22K, we can find that Y increases monotonically with P21K. When P22K equals to the given value, the first derivation of F with P21K equals to 0. Thus, we can conclude that Y decreases with P22K when P22K is less than the conjugation of P22K and increases with P22K when P22K is greater than the conjugation of P22K. The minimum value of P0 can be given by the greater value between P01 and P02, where P01 and P02 are the minimum value of P0 obtained from C5 and C6, respectively. By analyzing the relative value of P21K and P22K as follows, we can obtain both values of P01 and P02. In case 1, when P21K equals to N1, we can get the minimum value of P01 by the given equation. By analyzing the relative value of P22K, when the conjugation of P22K is between N1 and N2, less than N1 or greater than N2, we can get the value of P02. Similarly, in case 2, when P21K equals to N2, we can use the same method to get the value of P01 and P02 when the conjugation of P22K is between N1 and N2, less than N1 or greater than N2. In the simulation, the channel is modeled as ration fading where N equals to 3. F denotes the line of sight deterministic fact. Fk denotes the Rayleigh fading. The number of subcarrier K equals to 32 and the total bandwidth is 32 MHz. Other parameter settings are as follows. In this condition, the distance between UAV and IOD1, UAV and IOD2, IOD1 and IOD2 are set to be 5 meters, 3 meters, 3 meters, respectively. In Figure 1, it shows the relationship between UAV's minimum transmit power and the blocking time with different value of input data. We can discover that as the size of input calculation data increases, the minimum transmit power of the UAV increases as well. This is because the IoT devices consume more power to transmit data to UAV and compute locally as the input data size increases. We can also find that the minimum transmit power of UAV increases as T decreases. It's because in the case of shorter blocker time, in order to finish the transmission, the IoT devices require a higher transmission rate, which will lead to the UAV transmitting more power to provide energy for the IoT devices. Figure 2 shows the minimum transmit power of UAV versus noise power with different value of input data when T equals to 0.4 seconds. We can find that the minimum transmit power of UAV becomes smaller when receiver noise power becomes smaller. That is because with a certain amount of offloading data, the lower noise power, the lower power required. In this paper, a UAV-powered cooperative anti-interference mobile edge computing strategy is studied. To overcome the interference, utilizing the power harvest from the UAV broadcasting, different subcarriers was used by IoT devices to transmit the information to UAV for offloading. In addition, we formulate a power optimization problem by optimizing the power allocation of IoT devices under the premises of meeting the delay and the scale of computing task. UAV's transmitting power can be minimized. Simulation results prove the performance of the proposed strategy is effective and meets the expectation.
Ladies and gentlemen, I am honored to participate in this meeting. At this same time, I am also honored to have the opportunity to speak on this special occasion. The title of my paper is Fast Estimation for the Number of Clusters. The main points of my speech are as follows. The first part introduces the research background. The second part introduces my algorithm. The third part introduces my verification of the algorithm performance. Now, let's enter the first part of the topic. Clustering is an unsupervised learning algorithm with a wide range of applications. Its goal is to be as similar as possible to the same cluster. Different clusters are as different as possible. It has been widely used in many areas, such as image processing, in deep learning, pattern recognition, and so on. However, many clusters algorithms are supervised, and the number of clusters need to be provided before clustering, and the number of clusters is very important to quality of the cluster. For example, in this picture, you can see that as the number of the clusters increasing, the picture segmentation becomes clearer. If the number of clusters is much smaller than the actual number of clusters, some value information will be lost in the cluster result. If the number of the cluster is much larger than actual number of the cluster, the cluster result will be very complicated, and the characteristic of the data cannot be analyzed. In general, people need determine the number of clusters based on their background knowledge, but many users don't know much about the processed dates. Therefore, various validated indexes have been processed to determine the number of the cluster. In the real, many data have the clear boundaries. In the fixed dataset, there are many similarities between people, especially under a current experimentation. For example, the two ladies in the picture have many similars. Errors should be similar datasets. The picture on the right is based on length and width of the spells of errors flowers. It can be seen that there is no clear divided line between the two variables. Therefore, it is meaningful to determine the number of clusters in overlapping datasets. Here, we define datasets without clear boundaries as overlapping datasets, such as these pictures. Let us enter the algorithmic model together. In order to reduce the interference of noise points, we proposed to use the Formula 1 to calculate the distance peak source. It can be seen from the formula that we increase the weight of density. In this way, even when the noise point has a large distance, it cannot have a high distance peak source. Use Formula 2 to get our tightness boundary value. When the tightness value between the center point exceeds the boundary value, the following steps are not executed. Because in next time, we need to inject the change in the distance between the center points. When the distance between the center points is too small, also the overchange is small. From the local point of view, a big change has occurred. This will cause the estimated number of the clusters to exceed the optimal value. Therefore, the judgment of tightness is very important. Through the clonus judgment, we obtain break by follow 4. In the last step, we use the follow 5 to determine whether here is a big jump in the minimal distance between the sentences. At the last jump, it is the optimal number of classes. This is our algorithmic framework diagram. In the algorithmic compression part, I prepared a flow chart for everyone to introduce it in detail. I won't introduce it for too much here. Now, let us enter the experiment part to see the effectiveness and participability of our algorithm. Table 1 shows us the detailed information of the 10 algorithms we used for compression and our algorithm when determine the number of clusters. As can be seen from the table, the compression algorithm include PC, ZXF, LL, MLL, I-index, BIC, CH, CE, FHV, jump. There are certain datasets used to verify the effectiveness of the algorithm, such as SM2, Flame, SM4, SM8, ERS, SIS. There are the two-dimensional structure diagrams of the cyclic datasets. Each algorithm runs 20 times on each dataset, resulting in the number of the clusters for each dataset, as shown in Table 3. Table 4. Because the data types are different, the experiment is divided into parts. One is a cluster for overlapping datasets, and the other is a cluster for non-overlapping artificial datasets. We track the 20 executations of each solution on the overlapping datasets and recount the estimated value of K in Table 3. And we track the 20 executions of each solution on the non-overlapping datasets and record the estimated value of K in Table 4. According to the Table 3, ML estimates the number of clusters correctly only on the ERS datasets. BIC does better than ML. It obtains the correct estimations on SM2 and SM8 datasets. JUMP and I also exhibits related high accuracy. They estimate the number of the clusters correctly on 4 overlapping datasets. They are followed by CE and PC, which estimates the number of clusters correctly on 3 datasets. CH can correctly estimate the number of clusters on 5 datasets. Among those solutions, our approach does best. It estimated the number of clusters correctly on overlapping datasets. We also evaluate the accuracy of the full portion on non-overlapping datasets and describe the result in Table 4. According to the table, BIC and CH estimate the number of the clusters correctly on 2 datasets, where ML and ZXF do better. They correctly estimate the number of clusters on 3 datasets: JUMP, PC, LL, FHV, CE, and our approach does better. They obtain the result consistent with the natural number of the clusters on each of the overlapping datasets. In this figure show that accuracy of each approach on overlapping and non-overlapping. Data size. Based on the estimation on both overlapping data sets and non-overlapping data sets, our approach is high has the accuracy than the other solution. In addition to effectiveness, we also evaluate the performance of our approach on all the data sets. Correctly, we calculate the average execution of all the approach and depict the result in this table. According to the table, our approach spends less time on each of the data sets than each of the other approach does. Our approach spends 0.015 seconds to 1.7 seconds on those data sets, where other approaches take 1.32 seconds to 179.05 seconds. Our graphic has a better performance. Look through the follow chart to see that there are two reasons. The first reason is that our approach selectors cluster in the states way. It calculates a source for each data point. Once a source is calculated, it will not change anymore. Our approach takes the top k datasets with the highest source as the certain for k clusters. The other way to change the cluster center is through iteration. When certain conditions are met, the iteration will stop and the certain point will be opened. The second reason is that our approach narrows the search space of the optimal number of clusters and hence decreasing search cost. In conclusion, in this work we focused on the problem to estimate the optimal number of clusters in overlapping data sets. The experimental result demonstrates the usefulness and effectiveness of our approach. Thanks for your listening.
Presentation. Research on risk transmission process and enemy strategy of mine electric power ignition network. The power ignition network is becoming more and more important in the safe and efficient production operation of mine power system. Meanwhile, the power ignition network may be subject to security risks, such as malicious attacks, which pose challenges to my safety protection. Based on complex network theory, this paper proposes a complex network model of the power information network, aiming at the possible attack risk of the power information network. The SIR impact model is used to analyze and research on the information process of the power information network risk. On this basis, two investigation strategies are proposed to suppress the continuous protection of power information network security risks. The investigation process of the power information network is subject to verify the significance of the investigation strategy in the process of power information network strategy risk transmission. The power information network can be regarded as a complex network, which is composed of nodes and lines. The complex network model is established by abstractly simplifying an electrical power information network. Therefore, it is easy to analyze the technology, structure, and the protection process of the power information network. At present, complex networks are used to evaluate several basic structural attributes of their characteristics, including degree, constant conflict, and the shortest path. After being methodically attacked, the nodes of the power information network can return to normal by manually pairing. This protocol is similar to the SIR model in information disease theory. Therefore, the SIR model can be used for an effective and fitting when establishing a risk predictive model of the paper information network. The SIR model can be used to describe the transmission process, that is, the infected person has immunity after returning to health. This figure is changing process of three kinds of nodes, including uninflamed node, infected node, node repaired. This paper comprehensively considers the node importance evaluation algorithm in terms the node degree and the neighboring nodes technical confidence degree. Choose two power information network immunity strategies. The follow chart is shown in the figure. Start the degree of nodes immediately and or start the degree of nodes. The number node degree constants irrate and the non-inverse model and the model after these two imitations are compared and submitted. The compilation results are shown in the figure. In the figure, the number of individual infected nodes will gradually increase, with alternation of the two imitation scratches. The number of infected nodes is at a low level and no longer growing, Therefore, the infection process is controlled. Based on the complex network theory, the EAI model is able to analyze and study the evaluation process of the paper evaluation network risk. In this paper, a target email strategy and the email strategy are used, which comprehensively considers the degree of overlap between the node degree and the number node periphery. The power information network emailing process is similar to the vary in the efficiencies of these two email strategies in the paper information network security risk protection process. When the most important nodes are implemented more accurately for email implementation, the spread of infection can be further reduced. Thank you.
Dear teachers and students, I am a graduate student of North China University of Science and Technology. My paper is Rockburst prediction of multidimensional cloud model based on improved hierarchical and critic. In high-stress regions, Rockburst is a major disaster influencing underground engineering construction significantly. How to carry out efficient and accurate Rockburst prediction remains to be solved. Comprehensively considered the objective information of the index data and the important role of subjective evaluation and decision-making in Rockburst prediction, and use the improved analytic hierarchical process and the critic method based on index correlation to obtain the subjective and objective weights of each index, and obtain comprehensive weights based on principle of minimum discriminant information. The original cloud model and the classification interval of the Fourier index were modified to make up for the lack of sensitivity of original cloud model to the average of the grid interval. A hierarchical comprehensive cloud model of each index was generated through a cloud algorithm. Finally, the reliability and effectiveness of the model were verified through several sets of Rockburst examples and compared with the entropy-weight cloud model, critical cloud model, and set pair analysis multidimensional cloud model. The results show that the model can describe various uncertainties of interval-valued indicators, quickly and effectively determine Rockburst severity. One part is introduction. With the continuous developing of tunnels and underground engineering, Rockbursts are certain difficult to control and highly destructive, which seriously threatens the lives of work, delays construction period, and cause huge economic losses. It has become a major problem urgently to be solved. International deep mine engineering and underground space development engineering, and it is urgent to find a more effective method for Rockburst prediction. Rockburst prediction includes long-term prediction before construction and shorter-term prediction of construction process. The long-term prediction methods are mainly theoretical analysis and prediction. At present, The commonly used processing method include the mathematical comprehensive processing analysis method, model test verification method, and the numerical simulation analysis verification method. Among them, the mathematical comprehensive processing analysis method has achieved good prediction results in Rockburst prediction, and has been successfully applied to practical engineering, such as the fuzzy mathematical comprehensive evaluation method, SVM, decision tree, MLP, KNN, Rosetta theory, cloud mode, etc. It should be noted that different criteria and theoretical analysis method has their own limitations, such as the slow convergence rate of artificial neural networks, the comprehensive evaluation method of fuzzy mathematics cannot reflect the randomness of the system, and the distance discrimination method is highly dependent on samples. In terms of weight assignment, the expert-based subjective weighting method has obvious shortcomings due to the complex factors affecting the Rockburst mechanism and has not yet formed a perfect system. The objective weighting method doesn't consider the correlation between indicators and ignores the role of subjective decision-making in potential applications. The analytic hierarchical process is too subjective and may not satisfy the judgment matrix. The single weight assignment cannot accurately measure the influence of various factors, which makes the predictions result deviate from the actual result, and the combination weight lacks the corresponding bias. The cloud model has certain advantages for Rockburst prediction due to its ambiguity and randomness. However, with the increase of indicators, the calculation process of the one-dimensional cloud model is complicated, and it cannot reflect the interaction between multi-factors. This paper adopts a combination weighting method combination, improved analytic hierarchy process, and critic method based on index correlation, and combine subjective and objective weights to obtain combined weights based on the principle of minimum discriminant information. Make full use of subjective and objective factors to make empowerment more reasonable. The multi-dimensional cloud model is used to predict the Rockburst level, which reflects the comprehensive influence of various indicators and simplifies the calculation process of the model. The original cloud model and the classification interval of the predictive indicators were modified to make up for the lack of sensitivity of the original cloud model to the meaning of a greater interval. Finally, the established model is used to verify the reliability of the model in the application of Rockburst examples in related literature. 2 part is combination empowerment. 2.1 Improved analytic hierarchy process. This paper used the scale construction method to construct the judgment matrix, thereby improving the subjective weight calculation of AHB and avoiding the consistency check. The judgment matrix R satisfies the following conditions. Rij is the scale value of the first indicator's relative just indicator. The meaning of the standard value is shown in Table 1. Scale value 1 point. The meaning is equally important. 1.2 is slightly important. 1.4 is strongly important. 1.6 is obviously important. 1.8 is absolutely important. There are n indicators x1 to xn. Subjectively rank the indicators according to the principle of undiminished importance. Determine the scale value and record the corresponding scale and as Ti. Other elements in the judgment mixture are obtained according to the degree of transitivity, and then the final judgment mixture R is this. Alpha I is the weight value of the S index. Multiply Rij represents the product of all elements in the ith row of the mixture R. From this, the subjective weight of each indicator in the Rockburst prediction can be quantitatively determined as this formula. 2.2 Critic. The critic method is an objective weighting method based on evaluation indicators. It takes into account the comparative strength of the sample and the conflict between the indicators, and the calculation results are more objective and reasonable. Suppose there are m samples and n indicators, and xij represents the value of the just evaluation index of S sample. The evaluation mixture can be expressed as the calculation steps of objective weight are as follows. One step is the normalization of indicators. The larger and better indicators are Formula 2. The smaller and better indicators are Formula 3. The normalized mixture Y is calculated. True step is calculate the mean x and the standard deviation x. It's as a formula 4 and 5. Third step, calculate the coefficient of variation as formula 6. Fourth step is calculate the correlation coefficient mixture is as formula 7. Fifth step is to calculate the amount of information contained in the indicator as formula 8. Sixth step is determine the objective weight as formula 9. 2.3 Comprehensive weight. In order to make the comprehensive weight omega I as close to A and B as possible without basing any one of them, the comprehensive weight omega I is obtained according to the principle of minimum discriminant information, and the objective function is this. Solving this optimization model, the comprehensive weight as this formula. 3 part is multi-dimensional cloud model. 3.1 Multi-dimensional cloud model definition and digital features. A multi-dimensional cloud model definition is introduced on definition of one-dimensional cloud model as follows. Let C be a qualitative concept on the quantitative field U. If X is a random realization of the concept, the degree of certainty U of X on U from 0 to 1, is subjective to normal. The distribution X satisfies the normal distribution. In the formula, C max Gi and C min Gi represents the maximum and the mean values of S index interval of the G's index. Alpha Gi is the width of the left and right half branches connecting the cloud. Ex represents the basic certainty of the qualitative concept and is the spatial distribution of cloud drops in the universe of discourses. En entropy represents the uncertainty means of qualitative concepts. HE superentropy represents uncertainty of entropy and reflects the degree to which the random variable corresponding to the qualitative concept deviates from the normal distribution. 3.2 4 equals the indicators and the classification. The mechanism of Rockburst occurrence is complex, and there are many influencing factors. The selection of indicators is very important for the accuracy of prediction results. Based on the existing research results of Rockburst, this paper selects the ratio of comprehensive strength and tensile strength of rock. The ratio of the maximum tangential stress of the curve to initial comprehensive strength, the elastic interest index WET, and the integrity of the rock mass Ks. The one-dimensional cloud model requires that indicators follow a normal distribution within infinite intervals. In fact, the measured value of the indicators are usually vague and randomly distributed within a finite interval. This may be inconsistent with the actual distribution of the indicators, leading to the deviation from the actual results. According to the research work of Wang et al. And others, and Formula 15 is this: the standard interval of predicting Rockburst propensity indicators were revised as shown in Table 2, a modified Rockburst tendency prediction index. This is Rockburst level. This is Rockburst level. 1 is no Rockburst, 2 is weak Rockburst, 3 medium Rockburst, 4 is strong Rockburst, and these are 4 indicators. 3.3 Determine Rockburst level. To determine the level of Rockburst, the first step is, according to the revised prediction index of Rockburst propensity in Table 2, substitute the formula term to obtain the digital feature AX of the multi-dimensional cloud model. The two-step is, find alpha gi according to formula 16 to 17. Substitute into formula 13 and find the digital feature in. The feature value of HE is 0.01. Three-step is, the obtain n is substituted into formula 18 to generate a random number n that obeys the normal distribution. First step is, according to formula 19, obtain KGI and Rockburst instance data and substitute formula 20 to obtain a certain degree of membership of a sample. The last step is repeat the above steps to obtain the membership of each grade of the sample and determine the Rockburst grade according to the principle of maximum membership. 4.8 is case analysis. 4.1 Rockburst case. The 31 cases of Rockburst in this paper are all from published articles. 1 to 12 groups of data come from literature. 11 and 13 to 31 groups of data come from literature. 10. Table 3 is a part of engineering exam data. 4.2 Determine weight. Calculate subjective weights. According to the improv analytic hierarchy process AHP, according to section 2.1, combined with the literature. 14. The evaluation maxtra of the prediction indicators in Table 2 is R maxtra is this. According to formula, according to the formula, the final judgment maxtra R is this. Obtain the subjective weight according to formula as alpha. Calculate objective weights according to the critic method in section 2.2. Normalize the sample data, Table 3, and bring the sample data into formula 4 to 6 to obtain the average variance. The coefficient of variation is this. The correlation coefficient mixture is R. The objective weight according to formula 8 and 9 are beta. Calculate the overall weight according to the principle of minimum information discrimination. Substitute alpha and beta into formula 11 to obtain the integrated weight. Omega is like that. 4.3 Forecast model and results. According to the step of determining the Rockburst grade in section 3.3, substitute the Rockburst prediction index and grade interval in table 1. The values of number characteristic EXEN and KGI are shown in table 3. According to the digital characteristic, substitute into formula 20 to generate each index cloud model, as this for picture. According to the above results, the actual measured values of Rockburst examples are brought into the constructed model for prediction, and compared with the actual Rockburst level. Entropy, weight cloud model, critic multidimensional cloud model, and analysis multidimensional cloud model. The specific results are shown in table 4. The results show that the predicted results of the paper are basically consistent with the actual Rockburst grades. Compared with the prediction results of other models, the multidimensional cloud model reflects the uncertainty of Rockburst grade prediction in a fuzzy and random manner, and the calculation process of the one-dimensional cloud model is simpler. The multidimensional cloud model method proposed by critic is more reasonable based on the improved hierarchical method. For the first and second Rockburst, the prediction accuracy of the Rockburst is improved, and the reliability of the prediction is improved. Fair part is conclusion. 1. Choose 4 index. The ratio of the maximum principal stress to the rock initial tensile strength, the ratio of the maximum tangential stress to the maximum principal stress, the rock index and the rock integrity coefficient, and revise the upper limit of the infinite interval of the dex. Establish a multi-index forecasting standard for propensity. AHP and critic method are used to obtain subjective weight and objective weight respectively, and a comprehensive weight is obtained according to the principle of minimum identification information. Two-part is a multidimensional cloud model is adopted to establish a graded comprehensive cloud for Rockburst propensity prediction. The asymmetric interval in typical multidimensional cloud model is divided into 2 parts. The data is verified by 31 sets of Rockburst engineering examples. The rationality and the effectiveness of propensity forecasting compared with other forecasting methods shows the applicability of this model. 3-part. Compared with other methods, the cloud model can reflect the uncertainty of multi-index forecasting and visually display the forecasting process. The establishment process of the one-dimensional cloud model is complicated and the calculation time is long, but the establishment process of the multi-dimensional cloud model is simple. The calculation time is short, and the prediction results are more accurate. The selection of the digital feature of the multi-dimensional cloud model is conducive to improve the accuracy of Rockburst prediction, and the impact the index division of Rockburst grading can further improve the cloud model for Rockburst prediction, and the prediction result will be more in line with reality. Thank you, everyone.
Hello everyone, my name is Wang Haichao. I come from Henan Polytechnic University. It's my honor to participate the EAI 6GN 2023 EAI International Conference on 6G for Future Wireless Networks. The topic of my paper is Improvement of Online Education based on ACC, Reinforced Learning, and Catch. As shown in the PowerPoint, my report today is divided into 4 sections. First part is States of Online Education, includes online education background and information about the research. Online education as a supplement and extension of traditional classroom education. It has some advantages. It overcomes the limitation of time and space, lower teaching costs, alleviates the imbalance of educational resources. Students can learn the good teacher's class if they have network and network demos. But it also has disadvantages, such as higher network requirements, high bandwidth, and low latency. If the class video are high, they need a high bandwidth. If the class is live, they need low latency. Smartphone or computer required. For some students, they may have not smartphone and computer, so it is difficult to have online education for them. Third, teachers need to learn how to live broadcast or record videos for online education. Teachers need to learn more, and they add that at the teacher's work. During online education, some online courses are frequently requested by users and students. That can cause traffic congestion and produce repeated backhaul traffic. Our purpose is to reduce the resource access delay of end users. Second, solve the problem of network stalls. Third, improve network throughput. Our idea is through reinforced learning, educational resources with high frequency requests are packaged on educate nodes. Second, why we need edge nodes. What is educating and edge computing? What is edge-catching hierarchical? That perfect that picture shows the educating and uncomputing. Educating reduces wait time by storing data locally, resulting in continuously and better user experience. Edge computing can disperse computing resources and move them closer to the data source. That's the online education educate article. First, the edge node is placed at the edge of the network, close to the user, such as base station. Second, reinforced learning engines may catch a policy and update decision in edge nodes. When schools use edge catching, the required content is perfectly obtained from edge nodes, so it can significantly improve the online education experience for students and teachers. The online education content provider such as MOOC and Khan introduce our work, S3C workflow, and our experience settings. S3C based online education resource catching. S3C agents continuously improve the performance of network experience through continuously interaction and learning with the development at the network to maximize the cumulative records it receives from the development. S3C can learn from the development and catch the popular contents. That's the A3C workflow. First, reset the working agent to the global network. The agent interacts with the development. Each working agent learns the optimal strategy according to the different exploration strategies. Third, calculate the value and the strategic losses. Fourth, calculate the loss gradient and update the gradient in the global network. The aux agent restarts to reset the global network and repeat the counting process. For A3C, our experiment settings are shown as the PP PowerPoint. User requests in experience states are randomly generated by calling zip-f foundation in NumPy. A code interpreter is Python version 3.6. Code-dependent libraries include TensorFlow, NumPy, Act. For S3C engines, the Act and the critic learning rate is 0.001. That's the zip-f foundation graph. Field content is very popular, but most of the contents request lowerly. Finally, discuss our conclusion and our future work. Every 200 times as a train cycle, and record the train loss. The first 100 cycles, the loss remains at a high level. On the 100th, the most of the train dates loss were small. On the other hand, the work natural network to be global for update. After several updates, the global network each have a low level. As trains continue, they can become smaller and smaller, and it can stable. Next is our experience results. In the beginning, due to the small number of user requests, the high rate of for catch methods are at a low level. As the user requests increase, train based on A3C catch is also tend to be stable. The LRU A3C can perform better, such as green and red lines. As the number of the requests continues increase, the catch rates of R&D, LRU, LRFU also increased. Finally, the four catch methods reach the same level. The A3C based edge catch is sensibly stronger than the other three methods. So, use the A3C reinforced learning engine for catch the popular content can improve the content-rich catch and improve the network throughput output. Finally, discuss the dictation of our future work. First, how to use edge node catch more effectively. Such as if there has many edge nodes, the edge nodes catch the same or almost the same popular content. If they have more popular content, they will catch from the core internet. How to use engine nodes catch, such as more cooperative. Second, viable content popular. The popular content is changing various time. How to design a more effective reinforced learning or more effective A3C to learn from the development and to improve the hit rate. The third is heterogeneous catching nodes, such as engine nodes in the base station and our phone or our computing. The different drivers use them and catch. That's all. Thank you. Hello everyone, my name is Wang Haichao. I come from Henan Polytechnic University. It's my honor to participate in the EAI 6GN 2020 third EAI International Conference on 6G for Future Wireless Networks. The topic of my paper is Adaptive Cooperative Computing in Energy Computing Development. As shown in the PowerPoint, my report today is divided into 4 sections. First part is Big Data. Include research background and information about this research. The rapid development of 5th generation mobile networks, 5G, and the Internet of Things technologies will generate a large amount of data. The processing and analyzing requirements of big data will challenging existing network and processing platforms. For sensors with low latency requirements, such as industry control and real-time analysis, the high bandwidth and high latency of cloud computing are unacceptable. Edge computing and cloud computing, distributed computing, parallel computing act provide the necessary technological means to achieve accurate and fast integrated computing analysis. Cloud computing is based on platform virtualization, distributed storage, and parallel computing. Flexible computing resources are allocated. Edge computing can be used as an extension of cloud computing. It provides abilities and low latency and reliable computing. Second, discuss why big data should be used in catching and edge computing. What is edge computing? Edge catching reduce wait time by storing state locally, resulting in continuous and better user experience. Edge computing can disparage computing resources and move them closer to the data source, such as users, phone, or pad. The edge catch node is placed at the end of the network close to the user, such as base station. Reinforced learning agents make decisions in edge nodes. Edge computing has no powerful computing power of cloud computing. When a single computing node has many computing tasks, it is prone to high latency caused by long task queues. That's the edge computing challenges. First, the uncertainty of the computing task. Due to the uncertainty of factors such as the size of computing task, the length of computing time, and the delay of the task, the workload between edge computing nodes may vary greatly. Secondly, the workload scheduling of a single node. The task dynamic scheduling and computing resource allocation between nodes when cooperative computing between multi-nodes. Finally, the time interval. The most valuable part of edge computing is the computing of low latency. So cooperative computing should meet the requirements of low latency. Edge caching reduces wait time. Edge computing can reduce the wait time too by computing the user tasks. Third, computing power network. Overall, the system is divided into 4 levels. The first is the device layer, where the user device is located, including various network devices of users, such as computer and the Internet of Things and phones. Secondly, the base station, cell network, wireless network access point act, which the user device is connected. These equipments are located at the edge of the Internet, connecting users and the Internet, and closest to the user device. Thirdly is the edge computing nodes. They are among the cloud computing and the user device. Finally, the cloud computing platform is located in the core of network. Within a certain period of time, the node connected to the surrounding nodes and one level 2 node N, the level 1 node M, broadcasts its own remaining computing resource, PM. PM is CM and SM, and accepts the remaining computing resource P broadcast from other nodes. That means the edge nodes can have the remain computing resource of neighbor nodes. After node M receives the task request RDM. First, check the remaining computing resource PM, SM, CM at the node M. If the remaining computing resource P meets the user computing requirements CR and SR, then the server is started. If not, placed in the task queue for neighbor nodes or upload to the cloud. That's the workflow and the cooperative computing framework. The first part, DDQ for adaptive cooperative computing. DDQ act and learn from their own experience in an uncertain environment. Trail testing means with trade-off between exploration and development. Agents will try some effective actions that can generate rewards based on past experience. But in order to generate higher returns, there is also a certain prerogative to explore new actions. Another factor of reinforced learning is that the agents should look at the global, not only considering immediately rewards, but also long-term cumulative rewards. That's our experience site. For DDQ engines, the actor and the critic learning rate is That's our cooperative engine computing stress based on double deep Q-learning. That's our experiment results. First, randomly select 3 nodes of the agents for display. Then distribute the map of transmission time when task is offloaded. A transmission distribution lacks the Gauss distribution. Then we compared with deep QN during DQN, natural DQN. That's the reverse of different reinforced learning. And then agent train loads of different reinforced learning as shown in the PowerPoint. From the experience, DDQN is better and can keep a high rewards as it training. Finally, discuss the dictation of our future work. First is security of user on the edge. Second, accuracy agent training at the engine nodes. Third is collaboration among computing resources in a larger area, such as cities and cities. That's all. Thank you.
Hello, experts and scholars. I'm Wang Rui from the School of Architecture, Tianjin University. Today, I will introduce a paper for you. The title is Construction of Smart Carbon Monitoring Platform for Small Cities in China, based on the Internet of Things. The content includes introduction, literature survey, proposed framework, empirical research, discussion, conclusion. The first part is introduction. Intelligent low-carbon technology based on the Internet of Things is an important direction for the research of global low-carbon cities. Exploring and advancing the way to achieve smart carbon control has become the epoch topic of government and urban designers. For example, through RFID technology and the development of an electronic environmental protection sign system, cars can be classified and controlled according to different emission standards, on the basis of which a low-carbon traffic zone is established to gain an aim of low-carbon traffic, energy conservation, and emission reduction. In addition, some scholars have proposed a future urban low-carbon community model supported by digital infrastructure and data management systems, which constitute a smart, sustainable, and inclusive growth strategy through cloud computing and IoT. In China, a county or county-level city with an urban population of less than 500,000 is called a small city. According to the study, carbon emission in small urban areas with low levels of urbanization are usually 3 times higher than those in big cities. However, the low-carbon technology based on the Internet of Things technology has not yet been launched in small cities in China. The purpose of this paper is to build a smart low-carbon monitoring platform applied to small cities in China based on Internet of Things technology. It mainly solves 2 major problems. The first is constructing a real-time monitoring system to monitor carbon emission data from carbon source in Chinese small cities. The second is initially implementing a smart carbon monitoring platform for small cities with lower cost hardware investment. The carbon control monitoring in small cities mainly relies on the continuous development and renewal of carbon emission estimation and measurement technology. It is mainly divided into 3 research stages. The first stage, the calculation method of energy consumption carbon emissions based on IPCC calculation method. The second stage, the carbon emission efficient estimation based on big data. The third stage, the real-time carbon emission measurement method with IoT as a core. Based on the IPCC-based carbon inventory method, the carbon emission consumer department of small cities mainly include public power and heat, industrial production processes, transportation, service industrials, and residential lives. The power and heat energy consumption in the service industry and the residential life department has been calculated in the public power heat department. And other energy consumption such as gas is negligible. Therefore, the two departments are eliminated. The main department that jointly monitor long-term data, real-time data in small cities are identified, which are the thermal power sector, the industrial sector, and the transportation sector. On this basis, a real-time data acquisition system is constructed based on the received requirements of long-term data. They also constitute the three major systems of the framework of the Intelligence Carbon Monitoring Platform, which are thermal electricity monitoring system, energy monitoring system of industrial process, and transportation monitoring system. It takes a long time for smart sensing devices based on the individuals, families, or vehicles to be popularized in small cities. Considering the feasibility of the implementation of the Internet of Things in small cities, data collection should be carried out in management departments and enterprises with certain data foundations. Based on the sociological survey method of sample sampling, the real-time fluctuation estimation technology of carbon emission is realized. The Internet of Things usually have three characteristics. One is comprehensive things, that is, using sensors and other devices to acquire object information at any time. The second is reliable transmission. The sensor network is combined with the Internet to transmit object information to the Internet. The third is intelligent processing. Using intelligent algorithms such as cloud computing and body recognition to analyze and process the data, and then realize intelligent control of objects. Based on this paper proposed a framework for intelligent control carbon monitoring platform for small cities in China, which mainly includes the basic environment data layer, database and information management layer, computing layer, and management control layer. The county of Changxing is affiliated to Huzhou City, Zhejiang Province. It is located on the southwestern shore of Taihu Lake between Suzhou and Hangzhou. The county governs 3 streets, 9 towns, and 2 townships. Through the accounting of carbon emission in Changxing County for many years, its carbon emissions are mainly concentrated in the energy industry. which is mainly based on the electricity production and the production process of building materials industry, which is mainly based on the cement production. And the carbon emission of transportation and residential life are relatively low. In terms of carbon emission characteristics, Changxing has a representativeness of small cities in China. On the basis of basic data collection, database and the information management layer, computing layer, and management control layer are built. The carbon emission real-time monitoring system is constructed by sensing equipment monitoring. Combine carbon emission measurement correction method with intelligent calculation method, such as data cloud calculation and fuzzy calculation. And it can simulate the future trend of carbon emission according to the consumer sector. The small city carbon control system based on the Internet of Things is quite different from large and medium-sized cities. The focus of carbon control in large and medium-sized cities is mainly concentrated into two aspects: carbon emission control brought by residential energy consumption and a large population concentration, and carbon emission control of residential travel caused by traffic congestion. The focus of carbon control in small cities focus on industrial energy consumption and carbon emission from industrial production processes and carbon emission control from passengers and freight transportation. Therefore, low-carbon transportation and low-carbon residential Internet of Things technologies with application prospects in large cities are not very effective in controlling carbon in small cities. And increasing the IoT management and control method for industry processes and transit traffic is more targeted. The application of existing Internet of Things technology in low-carbon fields is often based on the superior database, rapid economic development, and the low-carbon management system in large cities. However, it is not fully applicable to small cities with poor economic levels and weak data environment. In view of the above problems, this paper constructs a carbon-controlled monitoring system linked to long-term data, real-time data, which is an exploration of the correcting method of traditional carbon emission measurement. Based on this, the intelligent carbon monitoring platform is initially constructed. This study provides a preliminary framework for the smart city carbon monitoring platform in small cities. But it still needs empirical support to explore the experience in data collection, processing, and analysis. Thank you for watching.
Hello everyone, this is Xiaofei Wang from Tianjin University, and we are now closing this wonderful online conference 6GN 2020. I guess you all exchanged a lot of great ideas. It is my pleasure to announce that for this conference in the following year, that is 6GN 2021, we finally decided to hold it in Harbin, hosted by HIT. Harbin is a nice place, and HIT is a great place for scholars to do research brainstorms. I wish that we can make the conference successfully next year. Thank you and take care. See you next year.